I think I'm live. Very good evening, all my dear students. Just to let me know, am I audible and visible to all of you? Hey everyone, welcome, vanakkam, suswagatam. Jo bole so nihal, sat sri akal, walaikum salam, assalamu alaikum. This is your Baba, HSP. Long time. Oh yeah, now I can see that the green barium fire is over there, chat section. Welcome to yours channel, that's Unacademy NEET English channel. My dear students, first of all, I would like to see green fire, the barium symbol in the chat, along with strontium and calcium, that's a fire. Barium, the green color, strontium, calcium, the crimson red, and the brick red, that in the form of fire symbol gets punctuality. You see the dedication and the consistency. I want to see the fire and the chat section should move very speedily. I want to see the speed. Then while teaching, I will show you the rabbit and the tortoise form. First of all, if everyone am perfectly audible and visible, the chat should run with the speed of Ferrari, Ferrari, Ferrari. Now, kid, that's really awesome. Welcome to the world of chemistry. That's really awesome. Now, I will go with GOC and starting from the scratch, my dear students, obedient students. I will not say that I will just teach. I will let you understand each and everything. That's my promise to all my dear students. My dear students, I will tell you from the 0 level up to the first rank. Now you know very well that the standard of education, or better to say the standard of NTA, setting the papers increasing. So I will reach up to the J level. You know that J mains is equivalent to NEET. So everyone, are you agreed with that? Whatever I'm telling you, you are going to make a note of it. You're going to write down along with me, and then you will see that you are able to do all the questions, and not only whatever the questions I'm giving over here. Definitely, categorically, I'm telling you this particular point, you will be able to solve each and every question, whatever the coaching, whatever the test series, whomsoever is giving you any questions from the organic chemistry, you will be able to solve. That's my promise to each and everyone. Some people are asking about how many hours. First of all, I want to see likes. Why likes are so less? My bond with you kids should be very, very strong. I will come near to you and will come inside this camera in the form of Champa. Champa is my assistant. Assistant means she is having vehicle nature. She will come through this camera into your house and she will start beating you. Everyone, Radhe, 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 Radhe. I'm going to start just now. If you are able to understand whatever I'm going to teach, you have to show, yes, green symbol, the green hearts or anything, green leaves. And if you are unable to understand, you have to show fire. Once this is clear, write down yes. And I want to see the likes. Why the likes are so less? I can't understand, kids. increase the likes. Likes means that is your attendance. Likes are just your marking attendance. So smash the like button, kids. Now, if you are new to this channel, let me tell you, my dear students, first of all, subscribe this channel if you're new to this channel, my dear student. And if you don't know who is your Baba HSP, let me tell you, I have been teaching for the last 27 years, produced so many ranks, including first rank, Tanishka Yadav, third rank, Ames, Mehak Arora's brother, Suez Arora, NEET, fifth ranked, 715 marks, Chaitanya Mittal, Ames, fourth rank, right? Hey kids, yes, now I have done my MTech from HBTI Kanpur and MSc in 1999, gold medalist. After, yes, getting that gold medal in MSc with that fantastic rank, I qualified JRF, GATE. Then I did my MTech in 2004. So this is all about your Baba HSP. Now GOC. Before I start GOC, my dear students, to many students, it looks like chemistry pidikya radu customer. It's romba sulubham. Organic chemistry looks like idiappa muruku. But I would like to say it's romba sulubham. Your Baba HSP will make. So, everyone, I'm going to start. Before I start this GOC, let me tell you the analogy. Atoms. For me, atoms are like human beings. Human beings are big. Our weight is in kg. Your Wasim sir must have told you that reference is kg according to physics, because we can see. Physics can see, and whatever we can see with our eyes, that is, yes, physics. And once we are unable to see small objects, so elements, atoms, they are very, very small. We cannot see with our eyes the single atom. We can't see. So their mass is in AMU, U, D. Yes. So my dear students, I always take atoms like human beings. We understand human beings, and electrons like money. Only two things: human being and the money. Everyone is having money, but we cannot see with our naked eye. Once we understand that human being is there, human being must be having money. And if we are able to understand the electron with that atom, we can understand each and everything. Okay, now let me tell you, my dear students, that in chemistry there is a reactant. There is what? Reactant. Reactant is also known as substrate. Reactant is also known as what, kids? Reactant is also known as substrate. Substrate. How will you find out which one is reactant, who is being reactant, my dear students? How will you find out? Remember that in your organic chemistry, reactant means the one whose carbon is involved, whose carbon is involved in bond formation, in bond formation. That means your reactant is always organic. Remember that this reactant will always be organic, should always be organic. If you talk about organic chemistry, then remember that whose carbon is involved, whether it is written over here it is written over here anywhere whose carbon is involved. And the second thing is reagent. This reagent can be organic or it can be inorganic. Just like if I say ethyl alcohol is reacting with PCl5. So ethyl alcohol is having carbon, but PCl5 is not having carbon. So PCl5 will be your reagent and ethyl alcohol will be your reactant. So it can be organic or inorganic. It can be organic or inorganic. It can be either organic or inorganic. They will react and they will give you product. They will give you product. My dear students, they will give you what? Product. Now remember that if this product is getting formed in single step, if this product is getting formed in single step, so we call it, we will be calling it elementary reaction. This reaction will proceed without formation of any intermediate. No intermediate formation. No intermediate formation. That means single step reaction. But if this reaction is proceeding in more than one step, we will call it, kids, if you are able to understand, say just whatever I'm asking, write down in the chat section. Just before I'm saying, you have to write down in the chat section before whatever I'm saying. Complex reaction. Complex reaction will proceed with the formation of intermediate. Will proceed with intermediate formation. Clear? Till now it's clear. Now this reaction will take place in more than one step. Intermediate. Now remember that intermediates are formed in between the reaction. Reactants final goal is to become product, but in between reactant and product, intermediate formation will take place. Are you getting my point? Now remember that one thing clear is clear to all of you, my dear students, what I'm saying. Step by step study of stability and reactivity intermediates is known as RM. What do you mean by RM? RM is reaction mechanism. Reaction mechanism. And to understand reaction mechanism completely, and to understand this reaction mechanism completely, we need two factors. We need two factors. What are these two factors? Write down immediately in the chat section. These two factors. Everyone. Before I write over here, you write down these two factors. One is electronic factor. Another one is steric factor. Steric factor. Remember that these are the two factors. One is electronic factor. Another one is steric factor. Just keep it in your brain, everyone. One is steric factor, another one is electronic factor. The whole study will move with these two factors. Don't forget. Yes, electronic factor and steric factor. Some people are writing, that's very, very important. This class is equally good for J students as well as NEET students. What I'm saying, kids. Now NTA is going to set a very tough paper. So class is equally good for NEET as well as JEE students, right? Now, my dear students, just see our electronic factors are of two types. Electronic factor are of two types. What are these two types? Anyone? Temporary and permanent. Temporary and permanent. First is being temporary and second is being permanent. My dear students, if I talk about temporary, if I talk about permanent, so in temporary there is only one, that is electromeric effect, useless. Electromeric effect is useless. My dear students, whatever I'm writing over here, try to keep it in your hippocampus, try to keep it in your nervous system. If you're not keeping right now in your nervous system, in the examination, definitely you will become nervous. What I'm saying, try to keep it in your nervous system. Try to dissolve the terms in your blood. These terms holds a hell lot of weightage, right kids? Now see everyone. This permanent is first resonance. First is being resonance. Also, we will deal with mesomeric effect. Mesomeric effect. Hyperconjugation. 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 Inductive effect. Now kids, the seniority is in this order, but I will start teaching from inductive effect. Remember that who is more important? Who is more important? Resonance is most important. Resonance is most important, then mesomeric effect, then hyperconjugation, and then inductive effect. But you know that in your English, without understanding ABCD, you can't understand essay. So I will start with whom? Inductive effect. But who is very, very important? Resonance. Let me write down this thing. Let me write down. Always remember this fundamental thing. Rahis. Rahis. What is the meaning of Rahis, kids? What's the meaning of Rahis? R for resonance. Remember that. Resonance. H for hyperconjugation. Hyperconjugation. I for inductive effect. S for percentage of S character. This is the priority order, so remember that I have to start with inductive effect, but the most important thing is resonance. Now see kids, take your copy and the pointed pen and hit it. Hit your copy with the pen. Everyone, hit your copy. Everyone, hit your copy with the pen. Have you done that? Have you done that? Now, what you're supposed to do? The page where you applied the force with the pen, okay? What you're supposed to do? Take your page. Let me also do that. Whatever I'm telling you, let me also do that. The same thing. Let us suppose this is my pen, this is my pen, and this is my copy. I'm also doing that, okay? Okay, done. Now kids, turn the page and just put your finger below it, below the page. Everyone, paper got displaced. A little bit the paper got displaced, but till the paper is with paper, there is no hole. There is no hole. Paper got displaced. Then see the second page. Little bit effect, less effect, but it is also there. Now see the third page and tell me the impact is up to which page? The impact is up to which page? There is impact up to which page? Do let me know. The impact of that is up to which page? Do let me know, kids. Everyone. Everyone, I want to see. Everyone, write about yourself. The impact up to which page? Kids, everyone is not writing. Write about yourself. Don't see the chat. Don't see the chat. Write about what you are able to see. Yes, number of questions we will deal with. Some are writing 4, some are writing 2, some are writing 3. But majority of the students, they are writing about 3. Now see, kids. I got it. And see, now you will be able to understand. Kids. Now, if I add over here any element like fluorine, now the pen, I applied force, that is like fluorine. Now fluorine is more electronegative. This fluorine is more electronegative than this carbon. It's 2.5 only. So this fluorine will withdraw electron towards itself side. Now fluorine is pulling electron from the carbon. Hey electron, come to this side. Hey electron, come to this side. That means fluorine is withdrawing the electron towards itself side. But fluorine is not able to displace, means it's not able to break the bond. Bond is still there. Covalent bond is still there. It's not like, remember that, it's not like once they have given like NaCl. There is no inductive effect. Don't do that, kids. Don't ever do that. Because the bond has broken. Here we are not having inductive effect. No inductive effect. Not at all. No inductive effect in ionic bond. In ionic bond, there is no inductive effect. That means inductive effect is valid only in covalent bonds. One thing you got, it is applicable in covalent bonds only. There should be covalent bond, then electron got displaced. This is electron withdrawing group or atom. Let me write down electron withdrawing group or atom. So whatever the electron fluorine was having, suppose I was having 8 electrons. Now if I'm just pulling electron towards my side, I will become more rich or beggar as compared to earlier, because these are the points you have to keep in your brain, kids. Then only you will be able to solve questions, otherwise not. Now fluorine has become more electron rich or less electron rich. Do let me know in the chat. Fluorine is saying, hey electron, inge va, evade va, come over here, come over here. You, I love you, electron. I love you, you are mine, you mine. So fluorine is becoming more electron rich or less electron rich. Everyone, you are not writing. I need your support, then only you can get the rank, kids. Otherwise, you won't be able to get the rank, kids. Everyone, because everyone's selection means a lot. If one is writing, 2 are writing, doesn't mean at all, kids. What are you doing? More electron rich. See, kids, see. This chlorine has withdrawn total 1 electron. This chlorine has withdrawn total 1 electron. So there is total one charge. There is total one charge, one, and it has lost one electron, so total one. But remember that in covalent bond, there will never be complete minus one. There will never be complete minus one. It can be minus 0.01, it can be minus 0.3, 0.2, 0.4, 0.5, but can't be complete one, because in a covalent bond the electron is slightly displaced. It is still in the shell of carbon only. It is slightly displaced towards fluorine. Are you getting my point? Slightly displaced. Suppose I am wearing this shirt. Now, if Champa has come and Champa is saying, hey, HSP, I want your shirt. So Champa is just pulling my shirt. Now, what will happen? My shirt has gone to Champa or slightly gone away from me. My shirt has slightly gone away from me. Hey, Champa, what are you doing? Hey, Champa, my shirt has slightly gone away from me, or Champa has taken away my shirt. Tell me, kids, partially displaced. If Champa, I'm suppose this side, Pandu is pulling me, and that side Champa is pulling me. My hand will, this tibia and fibula, radio and ulna, they will leave me, or they will slightly get displaced. Phalanges, carpals, metacarpals, radio, ulna, whatever, they are going slightly shifted or completely. My hand, Champa will take away. Slightly. So there will be slightly negative charge. Slightly negative charge. Are you getting my point, everyone? Partial negative. So definitely it has electron is moving toward that side. So this carbon will develop partial, what's your charge? This carbon will develop with charge. So this carbon will develop partial positive charge. Now, this carbon was directly attached with fluorine, so it will get maximum impact. This will get less impact, and this will get even lesser, and they will get minute. That is negligible. We will not say they will not get, but negligible. So, our science says we will count only up to third carbon. They have taken the average. So remember that inductive effect is valid up to third carbon. After that, it becomes negligible. Clear to all of you? Clear to all of you? This effect is valid up to third carbon atom, and after that it will become negligible. So let me write down the definition. Let me write down the definition, everyone, because definition, they can ask definition also. How will you define? So inductive effect is a permanent effect. Everyone note it down, because it's very important. That's why I have told you a number of things. They can give you assertion and reasoning. So we should understand each and every point. Inductive effect is permanent. Okay, I'm rubbing it. Let me know that you remember it or not. Permanent or temporary effect? Let me know. Temporary or permanent effect? Write down in the chat section. Inductive effect. Inductive effect is the permanent effect in this effect electron is slightly displaced, slightly displaced. Where displaced? Towards more electronegative atom, towards more electronegative atom. This operates through pi bond or sigma bond. Do let me know in the chat section. This operates through pi bond or sigma bond. This effect operates through pi bond or sigma bond. It operates through sigma bond. Valid up to which carbon? Valid up to which carbon? Valid up to third carbon atom. Third carbon atom. After that, it vanishes or becomes negligible. After that, it vanishes or becomes negligible. After that, becomes negligible. Now, on the basis of this, let me tell you, kids, hydrogen is taken as zero, having zero inductive effect. Zero inductive effect. For the reference, we will say it is zero. And electron withdrawing groups, we will say they act as minus I because they will develop partial negative charge, because they will become partial more electron rich, and electron donating groups will develop plus charge, right? They will become little bit electron deficient. Is this point clear to all of you kids? Everyone do let me know. Till now it's clear. So we have to focus on minus I and plus I. Who are minus I? Which are becoming more electron rich. Which are becoming more electron rich, right? They will become more electron rich, will become comparatively more electron rich, will become comparatively more electron rich. Is that clear? And they will become electron deficient. Now, on the basis of this, let me tell you this order, kids. Minus I effect order, we have to keep it in our brain. Now, you want to keep it by yourself, or should I give you one trick? Because once I'm going to let you know the order, I'm going to solve questions and you have to give answers just on the basis of inductive effect. Should I tell you the trick, kids? Should I tell you the trick, or you will do it by yourself? Just to let me know in the chat section. Fast. Kids, fast. Fast. Don't write down what it is going to do. Kids, fast. I want to see that you want to know the trick, or you will do it yourself. Fast. Those who want to know the trick, show me some green hearts in the chat section. Let me see. If you want to have the trick, show me some green hearts. Fast, kids, fast. I'm waiting. Your Baba is waiting. Everyone, yes. If you want to have the trick, show me some green hearts speedily, kids. Wow, yes. Now, I got it. Now see. The first line, they all are having plus charge. Now, what is the meaning of plus charge? Plus charge means the atom already has given its electron to somebody else. If I say nitrogen, if I talk about nitrogen, kids, just see, if I talk about nitrogen, nitrogen is having plus charge. That means somebody has stolen its electron. Let us Suppose if I say this is Nubia. Suppose this is Nubia. Nubia. Nubia was having 8 crore rupees. 8 crore rupees. 8 crore. Why I am saying Nubia? Just see, Nubia means nitrogen, 5 electrons of its own, and it has formed a bond with this. Now nitrogen is having how many electrons in the valence shell? 1, 2, 3, 4, 5, 6, 7, 8. Now if I say somebody has stolen 1 crore rupees of this Nubia, Nubia has lost 1 crore rupees, and somebody R is saying R was not having electron. Suppose if I say H was like this, without any electron, H has stolen 1 electron from this nitrogen. So now hydrogen is like this. Now nitrogen has lost 1 electron, so nitrogen is having plus charge. Nitrogen is having plus charge. Now hydrogen is saying, hey, I will form a bond with you. Now this Nubia is having right now also 8 electron. That time also Nubia was having, nitrogen was having how many electrons? 8 electrons in the valence shell. Now also 8 electrons in the valence shell. But what's the problem? This nitrogen's electron is shared by hydrogen. So there are 4 partners in the business. Here only 3 partners, and this was having hard cash money. So nitrogen is feeling low in energy. Hey, somebody has stolen my 1 crore rupee. Are you getting my point? So now this nitrogen would like to withdraw electron or would like to donate? Tell me. This nitrogen would like to withdraw electron, would like to snatch electron from someone, or would like to donate. This Nubia, somebody has stolen 1 crore rupee. Somebody has stolen. Now Nubia will try to donate or will try to snatch? Will try to withdraw. Very good, very good, very good. Now see kids. Now see kids. New friend. Everyone say along with me. New friend Narayan. New friend Narayan along with Shahrukh and Neha. Everyone say. Then only I will give you the trick. New friend Narayan along with Shahrukh and Neha. Say. New friend Narayan along with Shahrukh and Neha. New friend Narayan along with Shahrukh and Neha. Naughty Salman created scene in Rancho's car. See, I have written the trick also. New friend Narayan along with Shahrukh and Neha. Naughty Salman created scene in Rancho's car, right? Now, friend call bro and I. Friend call bro and I. Alkoxy, hydroxy, ion and Neha. Neha 2 times. See, this Neha is normal. This NH2 is without charge. And that Neha was positive charge. This Neha was having plus charge. Remember that. This Neha's electron has been stolen. And this Neha's electron is still there, right? And the benzene in and hydrogen. It's there in your brain. It's gone to your brain, kids. Once again, everyone say along with me. New friend Narayan along with Shahrukh and Neha. New friend Narayan along with Shahrukh. If you are not able to remember it, whether with the trick or by your own, however you want to keep it in your brain, just it should be there. Otherwise, you won't be able to solve even a single question. Let me tell you, kids, if you're not going to follow it, you won't be able to do anything. New friend Narayan along with Shahrukh and Neha. Naughty Salman created scene in Rancho's car. This is after that. This naughty is after this. Directly they can ask question. Write down in the decreasing order of minus I. or increasing order of minus I. New friend Narayan along with Shahrukh and Neha. Naughty Salman created scene in Rancho's car. Naughty Salman created scene in Rancho's car. Then friend called Bro and I, hydroxy, alkoxy, hydroxy, ine, Neha, benzene in hydrogen. Now, after this, something over here. Reason for more minus I of alkoxy than hydroxy. See, this question has been asked number of times, why alkoxy is having more minus I than hydroxy. Remember that. See, water bond angle is 104, alcohol bond angle is 109, ether bond angle is 111. More is the bond angle, more is the electronegativity of central atoms. So remember that alkoxy is having more bond angle, so it will have oxygens more electronegativity and so more minus I, right? Got it, kids? One more thing, let me tell you, carboxylic acid. If COOH group is in basic medium, what do you think? Base will take away its proton and will convert it into COO negative. Now this is electron donating group. So carboxylic acid in basic medium will behave as plus I. Same OH in basic medium will act as plus I. Otherwise they are minus I. Is this point clear to all of you? Both of these groups in basic medium will convert into this. They will behave as plus I. Otherwise they are minus I. In acidic medium they are minus I. Got it? Now let me tell you. Plus I. Remember that any atom having negative charge, that means extra electron. So how the charge will get decreased? If it is going to donate electron or it is going to withdraw electron. Remember that any group which is having negative charge can decrease its charge by donating electron. So all those who are having negative charge, they are electron donating group. That means they are plus I. Clear to all of you? They are plus I. Now, after this, more the number of alkyl groups, more is plus I. 3 methyl groups, so more plus I. Only 2 methyl groups, so less plus I. Only 1 methyl group, so even lesser. First thing, now why this is the order, let me tell you. The electronegativity of carbon is just 2.5. The electronegativity of nitrogen is 3. Oxygen is 3.5. And this is resonance stabilized by resonance. So this is least electronegative, so will easily donate electrons. So this wants to donate its electron most easily. Clear, kids? Everyone, this much is clear. Do let me know. Do let me know, kids. Everyone, just do let me know. Then I am going to deal with the questions. Till now it's clear. All the plus I and minus I are clear to all of you. Now see, kids. Applications of inductive effect. We will deal with carbocation stability, then carbanion stability, then free radical stability, then acidic strength, then basic strength. Five factors we are going to deal with. First, the carbocation stability, then the carbanion stability, then the free radical stability, and then basic and acidic strength. Everyone, now see, kids. Before I start, let me tell you something, kids. Very, very important. Something very, very important. Charge is like disease. Charge is like disease. Now tell me, kids, who is more healthy? the one who is having disease or without disease. Suppose if I say this is Champa without disease and Champa suffering with disease, which Champa's form is more stable? Suffering with disease. And this is healthy Champa. Which Champa is more stable? Tell me which Champa is more stable. First form of Champa is more stable or the second form? Which form of Champa is more stable? Do let me know in the chat section, everyone. Without disease. So remember that if compound is like this, we will say compound is neutral. We will say compound is neutral, and here charged compound. So same compound, which form is more stable? Definitely this form is more stable, right? More stable form. This is being less stable. Now kids, those who are preparing for IIT, I will not ask to those students, but those who are preparing for NEET, can you tell me disease? If you are eating less, then you are going to suffer with disease, or the one who is eating more? Do let me know in the chat section. Okay, don't worry. Tell me, more eating will give you disease or less eating? Tell me kids, more eating or less eating? Both. See kids. Let me tell you, some kids are writing, sir, in this way we are unable to understand. Don't worry kids, don't worry. Those who are unable to understand, let me tell you that stability is, first let me tell you, neutral compound is more stable. Neutral compound is more stable than the charged form. That means I can write down stability is inversely proportional to charge, right? Stability of compound is inversely proportional to charge. Those who were unable to understand, now I think they got it. That stability of compound is inversely proportional to charge. Now, I said charge is like disease. If you're eating food, the person can suffer with diabetes. If somebody is eating less, then the person will suffer with vitamin A deficiency, night blindness, scurvy, vitamin C deficiency, scurvy, protein energy malnutrition, kwashiorkor and marasmus, vitamin D deficiency, osteomalacia, rickets in child, osteomalacia in adults. So my dear students, remember that charge can be either positive or negative, doesn't matter. Charge can be either positive or negative, doesn't matter. So less is the charge, more will be stability. Kids got it? Less is the charge, more is the stability. Everyone got it? Less is the charge, more will be stability. Kids got it? More will be stability. Everyone, this much is clear to all of you. Now kids, you have to answer. If you got it, really got it, those who really got it, before diving towards the questions, tell me kids, if somebody is having plus charge, suppose if I say that this carbon is having plus charge, what this carbon wants? Carbon want to donate electron or carbon want to gain electron for stability. For stability, carbon wants to, write down in the chat section, carbon wants to donate electron or withdraw electron. Write down if you really got it. What I'm saying, if you really got it, do let me know in the chat section. For stability, carbon wants to donate electron or gain electron. Everyone. I want it from everyone's side. Otherwise, I will not teach kids. I'm not going to deal with the questions. No. Everyone. I want to see it from everyone's side. Thank you. Carbon wants to gain electron. Very good, kids. Carbon wants to gain electron. Very good. Now, if I ask, if carbon is having negative charge, then carbon wants to. If carbon is having negative charge, then carbon wants to donate electron or gain electron for stability. For stability, do let me know, kids. Fast, then only you can solve questions. Carbon wants to donate electron. Very good, kids. Carbon wants to donate electron. Till now, how many you got it? If this point is clear, then let me tell you, you will be able to solve all the questions. Do let me know, kids. Till now, if it is clear, show me green hearts. Till now, if it is clear, show me green hearts. Fast. I want to see fast, kids. Quick. Now, if you really got it, let me see that you got it or not, or you're just lying, kids. Okay. If I say this is carbocation, carbon having plus charge, it's carbocation. This is carbocation. Now, carbocations, who will be friend? The one who is donating electron will be his friend, or the one who is withdrawing electron will be his friend? Who will be its friend? Do let me know. The one who is donating electron will be its friend, or the one who is withdrawing electron will be its friend? Tell me. So then I will write down stability of carbocation. Stability of carbocation. This is carbocation. Who will be its friend? Do let me know, kids. The one who is donating electron or the one who is withdrawing electron? Some of you are writing very good and some of you are. Now, its stability is directly proportional to plus I because it is electron donating group. And who will be? This is plus I, its friend. I will say he is his friend. And who is enemy? Minus I. Why? They are electron withdrawing group. So they are like enemy. How many of you got it, kids? How many of you got this point? Then only you can solve the questions. Question will not come from here that the these simple points. First, do let me know that everyone. Now, this point is clear. Now, if I ask another question that I'm having carbanion, so stability of carbanion. What is carbanion, kids? Stability of carbanion. Who is carbanion? Carbon with negative charge is carbanion. This is carbanion. This is carbanion. What happened, kids? This is carbanion, carbon with a negative charge. Who will be its friend? Who will be its friend? Do let me know. Who will be its friend? Plus I or minus I. Who will be the friend of carbanion, kids? Who will be the friend of carbanion? Everyone, fast, fast. I want to see, kids. You are not writing answer immediately and everyone is not responding. I'm not going to talk to you, kids. I'm not going to talk to you. Electron withdrawing. Very good, kids. Very good. So, minus I will be its friend. Electron withdrawing group will be the friend. And electron donating group will be its enemy. You got it, kids. Got it. It is going to be friend. And it is going to be enemy. Now see, the carbocation's friend was plus I, but carbonion's friend is minus I. Friend depends what you are, what type of friend you should have. That does not depend on the other person. It also depends on you, that what type of suffering you are bearing, what type of suffering you are going with. You got it. Everyone, you got it. You got it. Everyone, you got it. Now, see. If I say there is carboxylic acid, you know that carboxylic acid, after leaving H+, it is having COO negative like this. It will look like this. Now, stability of this carboxylate, stability of carboxylate. Who will be friend? Who will be its friend? Do let me know who will be its friend. I want to know from your side who will be its friend. Then only you can solve any question of this entire world. Fast. Kids, you are taking too much time. You are taking too much time. Who will be minus I or plus I? Now write down, speedily write down. Minus I will be its friend. Minus I, that is electron withdrawing group, its friend, and plus I will be the enemy. Electron donating group is going to be enemy. This is the friend and this is the enemy. Mark my word, kids. If you are able to give the answer in the right way, you can solve all the questions. Then I will show you. Now, kids, if I say that base, this I will deal with acidic strength. This I will use when I will teach acidic strength. Then I will tell you, kids, right? Now, if I say, kids, if I say base after getting proton, they becomes having the plus charge like this. Now, if I talk about the stability of this conjugate, stability of this charge, who will be the friend? So your answer will be plus I will be its friend and minus I will be its enemy. Its stability depends like this. If these points are clear, mark my words, kids, you can solve all the questions. You will be able to solve all the questions. Now I'm writing and I'm going to give you the trick. See, I'm going to give you the trick. See, kids. Everyone just see. Miracle is going to happen. Miracle is going to happen. Carbocation. You must have heard something like the quote, friend, money begets money, iron cuts iron, right? Have you heard this thing? So the one who is having plus charge, its stability will be directly proportional to, this is having plus charge, its stability will be directly proportional to plus I. The one who is having negative charge, the one who is having negative charge, its stability will be directly proportional to minus. So stability is directly proportional to. Now if I say the one who is having negative charge, its stability is directly proportional to minus, complete it, minus R. The one who is having plus charge, the one who is having plus charge, who will be its friend? Plus I. This is the summary. This is the summary. Everyone got it? I want to see the claps if you got it. If you got it, this magic, this trick, if you by chance, if you're forgetting this thing in your examination, then do let me know this magic, magic, magic. If they are the friend, then another one will be the enemy. Everyone, kids, what are you doing? What are you doing? See, plus, so plus, see, plus, so plus. Everyone just see what I'm saying, where I'm focusing. By chance in the examination, if you're forgotten that this is having plus charge, just see, kids, this is having plus charge. So who is the friend for plus? Plus. So plus, minus. So minus, minus. So friend is having minus charge. See, friend is having minus, minus I is the friend, plus. So its friend will be plus I. Got it? If you are not able to, even if you are not able to apply your brain in the examination, then also this trick will work. How is the trick, kids? I want to see. Yes, kids, this is Baba HSP's trick. Baba HSP, HSP Baba, HSP Baba's trick. How it is, kids? Till now, I have not given you even a single question, but just trying to put all the concepts in your brain, kids. See my efforts. Till now, I have not given even a single question, but right now my focus is, my total focus on just explaining the concept. So whatever the question you are going to get in your examination, you can solve all the questions. Now, let me move towards the questions. Now it's the time to move towards questions. Before I move towards questions, let me tell you, this is carbocation. See how much hard work I have done for you. So that not to waste your time, just to save your time, this hard work I have done for you. See, kids. Okay, I will give some time for writing. Wait. I will move a little bit slow. Now see, carbocation, carbonium ion, and IUPAC call it carbenium ion. See, that is carbo, O. And this is carb, according to IUPAC. If they are asking, according to IUPAC, carbenium ion. Now, it is just this one, Cr3 plus. See, it is planar. It is planar. This is pure P. Pure P means unhybridized orbital. Unhybridized orbital will have two lobes perpendicular to the plane. Carbon with only 6 electrons in the valence shell with one positive electron deficient electrophile Lewis acid. Clear? This is pure p orbital with two lobes. Pure p orbital means unhybridized, which is not the part of hybridization. Now, see, it is planar. All the three are, they are the part of hybridization. This is hybridized. Its name is sp2. Its name is sp2. It is also sp2. sp2. It is also sp2. Now, there are three equivalent sp2 hybridized orbital, but this one is hybridized. It will be perpendicular to the plane. If I say this is plane, this is one plane, one p orbital's lobe is going up and one is going down. Clear to all of you? It is clear, kids. Now see, it is like this. So if what I am telling you, let me suppose if I say this was the plane, trigonal planar, then the p orbital's lobe was going above the plane. It was going above the plane. One lobe was going above the plane, another lobe was going below the plane, perpendicular to the plane. Okay. Now, if I do it like this, if I bring it like this, then the trigonal planar will be the copy and the two lobes will be going right hand side and left hand side. Got it? Going right hand side and left hand side. Got it? Now, see kids, tell me, this is 3-degree carbocation having me means methyl. This is having 2 methyl, this is having 1 methyl, and this is having 1 methyl. So definitely 3 plus I will donate electron and the charge will increase or decrease. Do let me know. 3 friends, they are donating electron to carbon. Hey carbon, take electron. So the plus charge magnitude will increase or decrease. Plus charge magnitude will increase or decrease. Do let me know. Okay, just wait kids. First of all, do let me know, am I perfectly audible or not, kids? First, do let me know. Can you hear me perfectly, kids? Am I perfectly audible or not, kids? Do let me know. Audible. Now do let me know. Now do let me know, kids. Now do let me know, everyone. Now is it okay or not? Kids, do let me know my voice is clear or not. Everyone, just do let me know. Okay. Now check it is okay or not. Now check it. Okay, just wait. Let me deal with this. Just wait. Hello. Hello, hello, hello. Hello, 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 hello. Hello, 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 hello. Hello, hello, hello. Okay, now let me check. Now you go and check the audio quality. Kids, now check. Now do let me know. I have tried a lot to adjust it. Everyone just do let me know. Now is it okay? Kids, do let me know. Now the audio quality is good or not? Champa is there, yes. Yeah, there was full black. I think Champa was there. Now check it out, everyone. Just do let me know. Everyone, I want to see green hearts. If I'm perfectly audible and right now visible to all of you kids. Hey, everyone. Kids, fast, because the bond connectivity, the way I'm going to tell you, whatever I'm going to tell you, that should be very clear, fit and fine, kids. Hey, everyone, that's fantastic, Now, are you ready for this question? Now, fantastic. Thank you, everyone. Thank you. Yeah, I will share the PDF after the class. I will share. Definitely, I will share. Yes, definitely, I will share. Now, see, kids. The three friends, they are donating electron through plus side. They are donating electron through plus side. Now, tell me, this is your litmus test. The charge will decrease or increase? That's my question. Do let me know. Charge will increase or decrease? Fire. charge will increase or decrease? Fast. So definitely answer is charge will decrease. The magnitude of the charge will decrease, and in English we will say charge dispersed. Charge dispersed. Everyone, what did you say? Charge is dispersed. Charge decrease, so definitely stability increased. Stability increased. I will use 3 much. Now there are 2 friends only, so I will say charge decrease 2 points. So stability increased 2 points. Now there is only one friend, so I will say charge decrease 1 point, stability increased 1 point. No friend. So whatever the charge is there, charge will remain like this. Who is more stable? This is more stable. This is maximum stable than this one, So if somebody is asking that which carbocation is more stable, so your answer will be 3 degree, then 2 degree, then 1 degree. Is it clear? This is the stability. Right now, I'm not talking about resonance. Nothing about resonance. Right, kids? Right now, I'm not telling anything about resonance. Okay, kids? Now, if I say this is your question, which will be most stable? Do let me know. Which will be most stable? Which will be the correct answer if you really got it? What's your answer? Do let me know. What's your answer? Do let me know. I'm waiting for your answer, kids. Fast. Right now, all the questions, they are based on inductive fact. No hyperconjugation, no resonance I have applied. Just inductive fact. People are going for C. Let me see this one, third one. Okay. Now see, this is 3 degree because this carbon is attached with 3 more carbons. 1, 2, 3. So B is most stable. After B, 2 degree carbocation because this carbon is attached with 2 more carbons. So 2 degrees. So A, then out of these 2, C, then D. B, A, C, D. Very good. This is absolutely correct. Now this question. Arrange the following in decreasing order of stability. Stability. Tell me what's your answer if you really got it. If you're really able to understand, do let me know what's the answer of this question, kids. Everyone, quick, fast. Do let me know. People are going for C. Let me see. See, this is minus I and there is plus charge. Who is the friend of plus charge? Carbocation's friend is plus I. Plus I, this is minus I. This is also chlorine. This is also chlorine. There is no enemy. No minus I. No minus I, only plus I. They are donating electron. So they are decreasing the charge. Charge is getting decreased. Stability is increased. Now all these A, B and C, they are having enemy. Minus I is enemy. Enemy should be near to you or enemy should remain far away. Do let me know. Enemy should be near to you or enemy should remain far away. Distance factor. Maximum distance. Now I have told you 1, 2, 3. The inductive effect is valid up to this carbon, very less. So it is applying minus I, and due to minus I, charge increased. Here this is nearer, so charge increased more amount, and this is nearest, so charge increased too much. So C is least stable. This one is least stable, and this one is most stable. D must start with D and end with C. Starting with D, oh, kids, not a single answer is correct. Not a single answer is correct. See, most stable is D. After D, A. After A, B. After B, it's C. No, 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 no. All are wrong. This is your correct answer. This is your correct answer. Everyone got failed, kids. Say, hey, how many of you got failed? Show me fire if you got failed. Show me green hearts if you are thinking like this. Moe, moe, hey, hey, what's this? Moe, moe, you got... What happened, kids? What happened? What is this? What is this? You got failed, you got failed, you got failed. Now, able to understand? Everyone got it? Everyone got it? Got it. Okay, very good, very good, very good, very good, Nabya, very good, very good. Now see another question. So always, let me write down fifth one also. None of these. None of the above. Nota. None of the above. Let's see. Let's see. Let's see, kids. Fast. Which option? Now you can treat it like a replica of your NEET or JEE. You can consider it to be a replica of your NEET or JEE, kids. You will get such type of brilliant questions. Fifth one, none of the above. Let me check it out. Now see, kids. There is enemy, 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 enemy. This enemy is nearest, so least stable. Least stable. That is far away. 1, 2, 3. After this, it's not valid. So negligible effect. Negligible. Right, kids? Most stable is A. A is most stable. After A is most stable. After A, B, then C, then D. A, B, C, D. A, B, C, D. A, B, C, D. Yeah. Fifth, none of the above is the correct answer. Kids, you got it. Hey, everyone, you got it. Now, everyone, you got it. Now, next question. Next question. Let's see how many of you are going to win this race. Let me write down fifth one. Fifth one, none of the above. None of the above. And right now it is the beginning. It's a beginning only. As soon as the time is approaching towards 12, you will get quality questions. Till that time, I must have taught you the hyperconjugation as well as the resonance. Now see, kids, we have to see this is the patient. This is the patient, right? And what effect will be given by these friends? They are enemy or friends? Let's see. Enemy, enemy, enemy. Oh, friend, this is friend. Plus I. Hey, you my friend. You are donating electron through plus I. Wow. You are donating electron. Electron is champa, champa. Hey, go, go, go. So its charge decreased. Stability increased. Wow. Now this is enemy. One enemy. One render mono, three enemies, and distance is same. See, a b, a b, a b, distance is same. At same distance there are three enemies, so least stable, because charge due to three enemies will increase 3 point, stability will decrease 3 points. Charge will increase 2 points, charge will increase 1 point, and this is the only one whose charge got decreased. So this is most stable. D is most stable. D, after D, C, B, A, D, C, B, A, D, C, B, A. First is the answer. D, C, B, A. How many you got it? If your answer is correct, always show green hearts. If your answer gone wrong, then fire. Let me check it out. How many of you are able to do this? Kids, I'm here to see what's your response, how you are doing, kids. If you're not able to do inductive effect questions, you won't be able to do resonance questions at all. You will never be able to solve resonance questions if you're not right now able to solve inductive effect questions, kids. Champa is coming to your home. She's on the way. Now, another one. Let's see. The fifth option is none of the above. Not none of the above. Let me check it out. What's your performance? Speedily tell me the answer. Everyone, fast. Kids, let's see. Who is going to rock? Baba will feel accomplished or not. Hey, two people have given the answer. One. Everyone is going with one. Let me check it out. Now, see the distance near to this A carbon, after this A carbon, A carbon. Distance is same. So distance is not applicable. Number 111, number is not applicable. Now power is applicable. Always see this D and P, doctor, nurses and patients. Distance, number and power. Whenever you are solving question, always see distance, number and then power. Distance, number, power. This is not applicable. Power, let's see. Who is having maximum minus I out of these four? Oh, this is the friend. This is the friend. Hey, you are my friend. You are decreasing the charge and increasing stability. So it will start with the D. It will start with the D. So these three can't be the answers. Now, who is the powerful enemy? New friend Narayan along with Shahrukh and Neha. Naughty Salman created scene. Naughty, this is powerful enemy. Powerful enemy. Got it? Most powerful enemy. Most powerful enemy. What I want to say, kids, you are getting most powerful enemy. That is maximum minus I. So this will be at the last. Starting with D, ending with A. DCBA. DCBA is the correct answer. Hey, congratulations. Those who got the correct answer. Those who got the correct answer, congratulations. Everyone is able to understand, kids. First, do let me know in the chat section. Those who are able to understand till now, green hearts. If you're not able to understand, fire. Let me see my students, whether they are doing it or not. I'm your Baba. I'm your HSP. I have to go along with you, kids. I can't leave you. I can't leave you, kids. Don't worry. I will explain again and again. Don't worry, kids. I want to see that how many people are able to understand and how many are not able to understand. Kids, don't worry. Your Baba is here. Why to worry, kids? Half, half. Okay, don't worry, kids. Radhe, 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 Radhe. Now, see, kids, let me tell you each and everyone now another question, and I will try to explain to everyone. This is the fifth option. None of the above. I'm waiting for your answer, kids. I'm waiting for your answer. Fast, fast, kids. Speedily do let me know. What's the answer? People are going for 4, some are going for 2. Some people are asking how NO2 is most powerful. Okay, I have told you the inductive effect order. If you remember that, at that time I have told you the trick also. Just to remember the power, minus I plus I power. Some are going for 2, some are going for 5. So see, you just check yourself. I will give time to note it down. Just see. Now see, this is plus I or minus I. Everyone do let me know, plus I or minus I. Do let me know. So this is minus I. First, minus I. Now this chlorine is minus I. Now chlorine is minus I. Now methyl is plus I. Okay, that's much we have done. Now, who is friend of positive charge? It's suffering with plus charge. This is the problem. It is having plus charge. This is unstable due to plus charge. Who will decrease the plus charge? Do let me know, plus I or minus I. Who will decrease the plus charge? Definitely plus I. So this is donating electron and the charge will decrease. Charge will decrease, so stability will increase. Now there are 2 chlorines. This is having more power, but I have told you, whenever you are in the situation of very tough, whenever you are in the situation of very tough question, what you're supposed to do? What I've told you, when there is tough question, what you're supposed to do, kids? Do let me know. Whenever there is tough question, what you are supposed to do? What I've told you, always see doctor, then nurses, and then patients. Doctor, nurses, patient. This I've told you or not? Do let me know, this I've told you or not? First priority should be given to distance. Distance. On second number, how many numbers are there? Third number is power. What's the power? Now, distance, number, power, DNP. This is the trick. Always remember. Always remember this trick. Can you keep it in your brain? Then only you can solve questions. Now see. Distance. Whose distance? This enemy is nearest. This is on the first carbon only. A, B, C. A, B, C. A, B, C. Now see, this is least distance, so this will increase the charge. Charge increase too much. Stability decrease too much. This point is clear. Now these two are at the same distance. Its power is more, its number is more. Who will be applicable? Distance, number, power. Now this will increase the charge and stability will decrease. Now this will be at the least. It will also increase the charge because its power is too much, but it is far away, so it's at the highest distance. So stability will decrease. So comparatively, who is maximum stable? D is most stable. D. After D, A. After A, C, then B. DACB. DACB. Fourth is the correct answer. This was tough question. How many of you got it, done it correctly? Do let me know. How many of you got it, done it correctly? Show me green hearts. It was tough question. Rank deciding question. Rankers question, kids. Do let me know. It's a rankers question. Kids, fast. I want to see your response speedily, kids. Speed up. Now, kids, before I move ahead, do let me know how it is going. I want to see your comments. Just I will give you 2 minutes. Do let me know how it's going. What you need more from my side. Do write down if it is going on the right track. You want more questions, you want more theory, or it's moving perfectly. Nalla iriku romba sulbam. Do let me know, because I'm over here to give you anything, whatever you want. I want to see your comments, kids. Okay, give some time to copy. One student has written not understanding. Everyone, rest of others writing wow, awesome. Wow, thank you, kids. Thank you. More questions. More questions. Give some time to copy. Romba Sulbam. Baba is perfect. Fine. Somebody is writing increase speed. Somebody is writing give some more time. At 8, I will give you break time. Okay. At 8. At 8, I will give you break. Okay. 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 Now, kids. Fifth is none of the above. Fast. Fast. Do let me know. First, okay, let's see. Okay, let me see, kids. This is minus I, 2 minus I. This is most powerful, but too far away, too far. Distance is too much. A, B, C. After that, this effect is negligible. Friend, this is plus I, 2 plus I, and this is also plus I. And these plus I are, there are more plus I, but they are too far away. See its distance. A, B, C, and it is on A and B. First, divide and rule. These are enemies, these two are friends. Definitely most stable will come from here only. These two friends are nearest to this. This is the patient, the suffering one, the one who is having charge. Because of this plus charge only, this compound is unstable. Because of this plus charges only, this compound unstable. These two methyl are nearest, so this is most stable. Got it? Most stable. And after this, this is BA. BA. We have divided, we have to play divide and rule. Now the enemies are nearest. This will be at the last. This will be at the last. So BA and then C and then D. BACD. Any option? BACD, BACD. Everyone now able to understand? Divide and rule. If you're not able to understand, divide it into two parts and then solve the question, right? Next. Carbonine. Now, carbonine, carbon with 8 electrons in the valence shell, electron rich entity, Lewis base, nucleophile. So who will be its friend? Minus I will be its friend and plus I will be its enemy. Okay. Now you can solve all the questions immediately. The things got reversed. The friend who was the friend of carbocation will become the enemy of carbonine, right? Will become enemy of carbonine. Now let's see. This is carbonine. Now its steric number is, what is steric number? Number of sigma bonds plus number of lone pair, LP. Number of sigma bond, 1 sigma, 2 sigma, 3 sigma and 1 LP. So steric number is 4. Once steric number is 4, its hybridization is sp3. Shape is pyramidal, right? Wanna donate electron. Lux, electron deficient, means minus I the friends and plus I being the enemy. Got it? Now let's see. Now tell me, these three methyl groups, due to plus side, they are donating electron. So they are increasing the charge. They are increasing the charge. Now examiner can say that charge is intensified. Charge is maximum intensified. Charge is maximum intensified. Remember that, intensified. What I'm saying, kids? Maximum increase in charge means charge is maximum intensified. Everyone, examiner can use this word. Charge is maximum intensified, means increased. Intensified means increased. Remember this term, increased, intensified. Now 2 plus I, charge increase 2 points, stability decrease 2 points. 1 plus I, charge increase 1 point. So who is more stable? Definitely this is more stable. So the order got reversed. 1 degree, then 2 degree, and then 3 degree. This is the carbonyl stability order, right? Carbocation stability order was in this direction. Carbonyl stability order is in this order, right? Now here is the question, and fifth one is none of the above. Everyone, fast, fast. Everyone, fast. Make it fast, kids. Good evening, Medico. Good evening, everyone. Do it fast. D. Some people are going for D. Let's see. So this is minus I, nearest, D and P, distance, number and power, right? So this is nearest, most stable, charge decreased 3 points or 2 points, whatever. Charge decreased. Here it is far away, charge decreased. And here due to plus I, this is plus I. So charge increased maximum. So who is most stable? CBAD, fourth. Very good. Congratulations. Those who have done it, congratulations. Another question. Fifth is none of the above. Everyone, fast. This is easy question. This is easy question, kids. Power, Medico is asking power. Just see the minus I order. plus I order. I have given one order in the starting when I was teaching. I have given one order. Go with that order. See kids. What is the power? I have told you the power over there. Now, see. This is minus I, minus I, minus I, and this is the plus I. This will be at the last because charge is increasing only in this one. And all the distance is same. Distance is same. Here the number is maximum. So number will decide number maximum. So charge will decrease with maximum power. Then charge will decrease. And here also the charge will decrease. A, B, C, D. A, B, C, D is the first one. Oh my God. First is the correct answer. Oh yes, everyone is writing first one. Fantastic, fantastic. Kids, this is really awesome. Now another question. Fifth one is none of the above. None of the above, not a. So, let's see who can give the correct answer. So, what I can see, kids, A, B, C, D. A, B, C, D. If this is your answer, don't forget to show green hearts. If this is not your answer, fire. Everyone participate in the chat. I want to see that, kids. Your participation is must, kids. If you're not participating, you are not doing justice with yourself, kids. At least do justice for yourself, kids. Now, another question. Fifth one is none of the above. So, wow, divide and rule. This is only the friend, minus I. This is only the minus I. Minus I is the friend of negative charge. We'll start with A. So this can't be the answer and this can't be the answer. Now maximum friends and they are nearest. This will end over there. So A. Oh, no, will not start with A. Kids, sorry. Even I got confused. Distance. First I have given to power distance. This power is nearest. This B, it will start with the B. Kids, even I got trapped. Even I got trapped. Even Baba got trapped. See, number is too much. Distance is also there. Distance and number. This is going to decrease charge. Oh my God. Increasing stability. Oh my God. Baba got trapped. Even I got trapped, kids. Even I got trapped. Then after this A, B, A, B, A, B, A, B, A. This can't be the answer. Then B, A, C, D, B, A, C, D. Fourth is the correct answer. Even I got trapped, kids. Now, kids, I want to have one promise from your side, kids, that you will not lose energy and you will remain up to the last. Inductive effect, then hyperconjugation, and then resonance. Kids, most important is resonance and its application. And what I can see, what people are doing, kids, people are decreasing. Have you not eaten anything, kids? Where's the Josh? What happened to you, kids? Now, kids, let me teach free radical stability. What are free radicals? Let me move to free radicals. See, kids. What are free radicals, kids? Carbon with 7 electrons like this. Now, steric number of it, number of sigma bonds, plus number of lone pairs, How many sigma bonds? You can see 3 sigma bonds. 1, 2, 3. No lone pair. So 3 plus 0. So it is sp2. Its shape is trigonal planar. Trigonal planar. And the outermost carbon is just having 7 electrons. So it is electron deficient. Electron deficient odd pair, and its shape is trigonal planar. Who will be its friend? Do let me know in the chat section who will be its friend. So definitely its stability is directly proportional to plus I and inversely proportional to minus I, right? So let me tell you the stability of this compound. Just see, if I draw the compound like this, 3 methyls, this is known as tertiary butyl free radical, then definitely isopropyl free radical, then definitely ethyl free radical kits, and after that methyl free radical, because hydrogen is neither electron donating nor electron withdrawing. So definitely its stability order is like carbocation stability order: 3 degree, 2 degree, and then 1 degree, right? I hope that everyone got it. Done and dusted kids till now. Now I am going towards acidic strength, which holds a hell lot of weightage. Is everyone ready for that? Acidic strength, yeah, it's like carbocation only. Stability order is like carbocation stability order. Got it, kids? Everyone got it? Now, acidic strength. Fourth application. Fourth application. Everyone ready for that? Fourth application, kids. Acidic strength. What do you understand by acid? You must have seen RCOOH, kids. You must have seen RCOOH. Now see to it. RC double bond OOH. Now if you place inside the water, if you put it inside the water, what this water will try to do? This water will try to snatch its proton. It will try to snatch its proton, and water will definitely snatch its proton, and this oxygen will be there along with electrons. So what charge this oxygen will develop? Definitely this will develop negative charge, RCOO negative H3O plus. And we know very well that charge entity is unstable. So the charge entity would try to come back. It will try to come back, and that's why we say organic acids are weak acids. There will lie equilibrium. So this will go, this water wants to polar protic solvent, PPS, polar protic solvent. This solvent wants to take its proton, but this unstable entity wants to gain its stability, so it will try to snatch proton from this hydronium ion. So this tug of war is moving in this way. It's going in that side, it's coming back, so it is reversible. So this is an acid, and we will say it's conjugate base. What do you call it? We are going to call it conjugate base. Now, my dear friends, just remember, if any conjugate base is more stable, then that will apply less efforts to take its proton and to go backward. It will say, okay, I'm comfortable this side only, why to go back? And if this conjugate base is means not able to live without its proton, then it will say, hey, please give my proton, I want to go back. So can I say that is acidic strength of an acid is directly proportional to the stability of conjugate base? Can I say like this? Acidic strength of acid is directly proportional to the stability of conjugate base. Okay, let me tell you in another way. If I say this is champa, this is champa, this part is champa, and champa in winter season she is having jacket. This H is champa's jacket. Now one villain has come and villain is saying, hey champa, I will steal your jacket, I will take away your jacket. Now what champa will say? Hey, take my jacket? Or champa will try her best efforts so that water should not be able to steal this jacket. So the same situation is that if it is like champa or like Tarjan or like Pandu, number of entities will be there. If they are stable without jacket, they will say, hey, go, take my jacket, I don't need it. But if somebody is feeling unstable, they will say, I want my jacket back. Are you getting my point? Kids, everyone, are you getting my point? Everyone, now see kids. Can I write like this? Can I write like this, kids? That acidic strength of an acid, acidic strength of an acid is directly proportional to stability of conjugate base. Can I write like this? In the starting, I have told you that acidic strength of an acid is directly proportional to stability of conjugate base. Can I write like this, kids? Agreed. And if you have studied ionic equilibrium or you will study further on, then Ka is directly proportional to acidic strength. Acidic strength is directly proportional to Ka and inversely proportional to pKa, because if you see maths, pKa is equal to negative minus log of Ka. If you know this, you can remember. Either ways you can say and go with this, that acidic strength is directly proportional to Ka and inversely proportional to pK. If this much is clear, then I will move towards questions. Let me explain one. Okay, let me explain one, then I will give questions, right? See kids, if I say there is NO2, if I say there is H, and if I say there is CH3, and the rest of the part is same, like if I write down CH2, COOH, CH2, COOH, and CH2, COOH. All three, if I say X, Y, and Z, they all are having COH. Where's the difference? The difference lies only in these added things. They all will release proton in aqueous. They can write like this also. Sometimes they will write down aqueous. So be careful. Aqueous means water is there. After releasing their proton, how they will look like, just see. How they will look like, just see kids. They will look like this. NO2, they will become conjugate base. CH2, COO minus, H, CH2, COO minus, CH3, CH2, COO minus, they will become conjugate base. They will become what, kids? They will become conjugate base. They were acids. Now, let me write down, this is M, this is N, this is O. Out of these three, M and O, who is being most stable? Who is being most stable? M and O. Fast, fast. Very good. One kid has written, this conjugate base is most stable. If this is being most stable, if this is most stable, so definitely its acid will be most acidic. This will be most acidic. Got it? And this one is least stable. So its respective acid will be least acidic. I hope that everyone got it, kids. Now, can I write like this? This is having maximum Ka. Maximum Ka. Can I write like this? Can I write it is having least Ka? Can I write it is having least pK? Least pKa. And this is having maximum pK. If this much is clear, do let me know, kids. Then I will dive into questions. Then I will let you know number of questions. Then we will deal with number of questions. Kids, do let me know. Everyone. Everyone, just do let me know. Got it or not? Kids, fast, fast, do let me know. Everyone, everyone. You got it? Now, here is the question number 1 and the fifth one. Let me write down. Fifth one, none of the above, nota. Let's see, kids. Let's see. It's simple. Rhombus sulfum. Fast, kids. Fast, fast. Very good, Movin Qasim. Very good, very good, very good. Second, yes. So see, which rule is applicable? Distance, number, power. This question is based on what? Distance, number, power. Do let me know. Distance. All they are being NO2. They are being same. Their power is same. Power is same, kids. Power is same. So which rule is applicable? Only distance. Their distance is too much here. DCBA, DCBA. Second is the correct answer. Don't forget to show green hearts if your answer is correct. If you got correct answer, if you've done it correctly, show me green hearts fast. Now, fifth one is none of the above. Fifth one is none of the above. Not none of the above. Yes, this is also very, very easy question. First, second, third, fourth. DCBA. Once again, DCBA. Second is the answer. You got it. Second is the answer. Second is the answer. Got it, everyone? DCBA. Now, this one. Fifth, none of the above. Not everyone. Now, this is based on distance, number, and patience. D and P. D and P. So, all they are being say, oh, this is different, but their distance is same. So distance is not applicable. Distance is not applicable because they are at the same distance. Number, their numbers is same, but its power is more. DCBA. Once again, I will go for DCBA. Kids, till now it's okay. Till now, very good, very good, very good, kids. Very good. You are getting it. Now this one, fifth option, none of the above. None of the above. Speedily, do let me know. Fast, fast, kids, fast. I'm waiting for your answer. Fast, speed up, speed up. Now see, the power is different. Distance, number not applicable, only power is applicable. Power, this is decided by power. Power, naughty, naughty, naughty Salman created scene in Rancho's car, broke all eye. So NO2, then this DCBA. Once again, second DCBA. Everyone got a DCBA. Very good, very good, very good. It's rocking. You kids are rocking. Now this one. Oh yeah. Oh yeah. Oh yeah. None of the above. Fast, fast, fast. Let's see. A, B, C, D. I will go for one. I will go for one. I will go for one. Everyone got it. One. Oh, what happened? Why? It's minus I, minus I, minus I, and minus. No, it's plus I only. So A, B, C, D. First is the correct answer. First one. First one. Kids, first one is the correct answer. First one. Everyone got it? None of the above. Fifth option is always none of the above. Not. Let's see who is going to solve this question. Now, how will you find out which one is plus I, which one is minus I? Let's see who is able to find out which one is plus I, which one is minus I. Kids. Now see kids, this one is minus I, minus I, minus, and this one is plus I. This one is only plus I, so it will donate electrons. So it is electron donating group. So the minus charge will increase. Charge will increase. So this will be at the last. This will be least acidity. D at the last. So this can't be the answer, and this can't be the answer. Both of these can't be the answer, right? Now, who will be maximum acidic? Minus I of OCS3 is maximum. Start with A. It must start with A. A, B, C, D. A, B, C, D. This is the correct answer. This question was really awesome. How many of you got the correct answer? I want to see some fire. If you're not able to understand, if your answer gone wrong, if answer went wrong, and if you have done it correctly, some green hearts, green hearts. Fifth is none of the above. Nota, none of the above. Nota, yes. Distance, nurses and patients. Which rule is applicable? Distance. Oh my God, this is tough question. Number is more, distance is more. So it will start with A. So these two can't be the answer. After this, same distance, but power is more. A, B, C, D. A, B, C, D. A, B, C, D. First. Hey, how many of you got it? How many of you got it? First, everyone able to understand? Able to understand? See, distance here, this distance is least distance. Those who are not able to understand, least D, and number 2. Number is 2. Got it? More number and least distance. Now same distance, but more power of minus I. More minus I power. I hope that you got it. More minus I power. And this is least minus I power. Kids, do it. Oh, fifth one. None of the above. This I have to explain. Remember that, kids. Can you tell me negative charge is more stable on more electronegative atom or less electronegative atom? I want to see. Negative charge is maximum stable. Then only you can do this question. Negative charge is more stable on. Tell me. Negative charge is most stable on, most stable on. Complete, fill in the blanks. Then only I can help you kids. Fill in the blanks. Remember that your answer will be negative charge is more stable on more electronegative atom, but that is wrong answer. That is wrong answer. Remember that negative charge is more stable on the biggest atom. Biggest atom, mark my words. Biggest atom. Remember, this is very, very important point. Very, very important. Otherwise, you will get failed. Let me show you, let me tell you. See, HF, HCl, HBr, HI. Do you know the acidic strength? Do you know the acidic strength order? Definitely, the acidic strength order is in this way. If you remember this, if I tell you the pKa value, it's -10, it's -9, it's -7, it's +3. Least pKa, maximum acidic. Least pKa, maximum acidic. It's, let me tell you one thing. This is experimental. pKa is determined experimentally. But how will you do it theoretically? Who is having maximum size? Fluorine, chlorine, bromine, iodine. Tell me, who is biggest in size? Fluorine, chlorine, bromine, or iodine? This is maximum in size. So iodide negative is most stable. Iodide negative is most stable. Then bromide, then chloride, then fluoride. Now you will ask why, sir, and how? This is the stability order, kids. Stability order. Now remember that maximum is the size, maximum is the dispersal of charge. Let me write down on the next page. Maximum is the size. Maximum is the size of an atom having negative charge. Having negative charge. What I'm saying, kids, maximum is the size of an atom having negative charge. Maximum is the dispersal of charge. Maximum is the, say everyone, maximum is the dispersal of negative charge. Say everyone, wherever, kids, wherever you are seated, say. Remember that I'm nearest to you. See, I'm nearest to you or not. Just see, just in front of you. Whatever I'm saying, you have to repeat it. Will you follow, kids? Will you follow? Then only you can get the rank. Then only you can solve the questions, kids. Will you do that? Will you follow, kids? Then see, the magic is going to happen, kids. Yes. Say, very good, kids. Very good. Very good. Maximum is the size of an atom having negative charge. Maximum is the dispersal. And maximum is the dispersal. That means least is the magnitude. Least is the magnitude of negative charge. And what I've told you, if charge is decreasing, stability will. If charge is decreasing, stability will. If charge is decreasing, stability will charge decreasing, then stability is increasing. And if the stability of conjugate base increases, then the acidic strength will also increase. K value will also increase. pK value will decrease. Everyone, is this clear to all of you kids? Is this page clear to all of you kids? Now, what you have studied, now you must be thinking of, sir, I have to study that negative charge is most stable on most electronegative atom. Negative charge is most stable on most electronegative atom. Then what was that? Let me write down what was that. The thing which you are having in your memories, what was that? Let me show you kids. Then only you can do questions. If you follow your Baba, then you can solve any question. Now remember that if size of an atom bearing the negative charge or having the negative charge if size of an atom is same or approximately same, now you will say, sir, we are the grown-up child. Atoms are very small. Machines has told us that we are in kgs. Atoms are in AMU. We can't see the atoms. We have never seen atoms. Then how can we compare the size? So who will tell us how and what is the size? Kids, let me tell you, if atom belongs to the same period, that means if atom belong to the same period, then their size is approximately same. Do you remember periodic table? Atoms from same period in long form of periodic table, have approximately same size. Am I right, kids? Have approximately same size. Kids, this point is clear. If you have never seen atoms, even I have never seen atoms, but I know the periodic table, then I can compare. Now see, then negative charge will be more stable. Negative charge will be more stable on more electronegative atom. Now let's see to it what I'm saying, kids. If I say that I'm having carbon, I'm having nitrogen, I'm having oxygen, I'm having fluorine, can I say they belong to the same period? Yes, sir. They belong to the same period. Okay. Now, if I say that I'm having CH4, I'm having ammonia, I'm having H2O, I'm having HF, they all are being acid. If I say they all are being acid, if I treat them to be acid, they all are being acid. Now, I'm going to make their conjugate base Then after donating one proton, it will look like CH3 negative. Am I right? It will look like NH2 negative. Am I right? Yes, sir. OH negative. Yes, sir. HF fluoride negative. They belong to the same period in the long form of periodic table. Then the negative charge is most stable on the most electronegative atom. Now if I say that what's the electronegativity of carbon? I don't know, sir. Okay, you know fluorine? Yes, sir. 4, decrease 0.5, 3.5, decrease 0.5, 3, decrease 0.5, 2.5. Now negative charge is most stable on the most electronegative atom. So this is most stable. So this is most acidic. This is least stable. So this is least acidic. Everyone, till now it's clear. Now, what I say that stability order is increasing in this way, so the acidic strength is increasing there. So the acidic strength is increasing. Agreed? Here the stability order of conjugate base is increasing. Conjugate base stability is increasing. So the acidic strength is increasing, right, kids? Now if I say, kids, if I say that if I call it A, it to be B, it to be C, it to be D, will you answer my question? A, B, C, D, who will have maximum pK? Out of A, B, C, D, which will have maximum pK? Write down in the chat. Out of A, B, C, D, which will have maximum pK? Let's see who is going to give the first answer. Who will have maximum pK? A, B, C, D. Very good. A will have maximum pK. A will have maximum pK, and let me tell you, its pKa value is approximately 50. Like my age, 50. I'm 50 plus, and this is having least pK. Its pKa is 3. No need to remember pK, but I'm giving you an idea. It is 15.7 at 25 degrees Celsius, and this is 35. Now kids, should I ask one more question? If you say, then only. If you say yes sir, ask, then only I will ask. If I say this is M, this is N, this is O, and this is P, which is most basic out of M, N, O, P? Thank you, Shadi, thank you. I'm 50 plus. Yes, I'm 52. Out of M, N, O, P, who's most basic? Wow, kids, you're rocking. I'm looking like teenager. Oh my God, thank you. Thank you. You're rocking, kids. You have touched my heart by saying answer M. Yes. So this is basic strength order. I would like to say this is basic strength order. This is basic strength order. Wow, kids. While studying acidic strength, you have studied even basic strength also. Now, just to keep it in your brain for longer period of time, let me give you one image. Let me give you one image. Just see, kids, so that you can keep it in your brain for a longer period of time. Carbon, nitrogen, oxygen, fluorine. Okay. After fluorine, okay, let me do one thing so that you can keep it in your brain for a longer period of time. Carbon, nitrogen, oxygen, fluorine. They are approximately of same size. Okay. I think I've drawn them to be same size, right? Kids say no, yes. No. Chlorine, bromine, iodine. Where are you going, kiddo kid? Now, where should I draw iodine? Hey, Baba, no. Once again, kids. Sorry, forgive me, kids. Once again. Sorry, kids, once again. Carbon, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. Just try what I'm trying to do, kids. Just see to it. Now it's okay. Now try to understand what I'm trying to do, kids. Now, CH4, ammonia, H2O, HF, HCl, HBr, HI. The acidic strength is like this, in this way. This is the acidic strength order. Got it? Can you keep it in your brain? Let me write down its pK. 50, 35, 15.7, 3, -7, -9, -10. This is the acidic strength order. Can you keep it in your brain, kids, for always? Have done a great thing or not, kids? Do let me know. Are you happy or not? Now I want to see the board. Kids, I was having my tea, but then also I have not stopped teaching you, kids. I'm a dedicated teacher or not? Hey, kids. After half an hour, I will give you one break. After half an hour, right? Kids, why the likes are not 400? What happened to you? Let me see. Likes are not even 400. Smash the like button, kids. What are you doing? Kids, make it 400. What are you doing? Thank you. Thank you, kids. Thank you, kids. Everyone is able to understand. Now, basic strength. This is the fifth application of inductive effect. Now, inductive effect will get over. So, now, tell me the answer of this question. Let's see. Let's see. What's the answer? Definitely DCBA. DCBA is the correct answer, right? Another question. Now tell me what's the answer of this question. DCBA. Once again, DCBA. Everyone is able to understand. Now tell me. Now tell me. Let's see how many of you can give the answer. It's your turn. The ball is in your court, kids. The ball is in your court. Now you can understand why the acidic strength on moving down the group increases. How many of you got the answer for the first time? That you must have studied in P block. As you go down the group in organic chemistry, that is in organic chemistry, the acidic strength increases on moving down the group. So moving down the group, so nitrogen, phosphorus, arsenic, antimony. So DCBA. Once again, second is the answer. Now, this is tough question. How will you do it? Now see, who is biggest? This is biggest, then this, then this, then this. DCBA. DCBA. Once again, first see the size. Everyone first see the size. Now, oh, read it out properly. Read it out properly, kids. Read it out properly, kids. Read it out and then answer it. Arrange the following in decreasing order of pK. So never do this question directly. Never do this question directly. First see who is most acidic. Who is being most acidic out of these? Distance, number and power rule. Distance, number and power. So distance, it's too much. This is maximum acidic. Maximum acidic means least pK, least pKa. And this is least acidic. Least acidic means maximum pKa. So what they have asked, in decreasing order of pK, once we are writing English, we move from left to right. Left to right. Some people are having problem over here also, whether we have to see from that side or this side. Go that side. So it will start with the D and end on A. Starting with the D, there is only one option. D. Second, how many of you got it correctly done? Show me green hearts. Remember that if your answer is correct, then green hearts. Arrange the following in decreasing order of acidic strength. I hope that everyone can do it easily. So this is maximum plus I. Maximum plus I. So least acidic. And here, remember that triple bonded carbon is sp hybridized. So its electronegativity is 3.25. This is the electronegativity. sp2 hybridized electronegativity is 2.75. sp3 hybridized electronegativity is 2.5. So can you see? This is withdrawing electron or giving less electron to this. This is maximum electronegativity. So it is most acidic. A, B, C, D. A, B, C, D. First is the correct answer. Hey, kids, you're rocking. Hey, yeah. Kids, yeah. Salute. Cheese up. Romba Sulvam, you are doing the best. Wow, kids, rocking. You're rocking. Rock star. You're looking like Rocky. This is the last question of acidic strength from inductive effect. Once again, it will come when I teach you resonance. Yes, it's directly proportional to electronegativity because minus I, more electronegativity means more minus I. So let's see COH, COH, COH. Now A, B, on B cyanide is there, A, B, fluoride is there, A, B, iodide is there, and they are plus I. These are plus I, so least acidic. This is the least acidic. Least acidic, right? Least acidic. So ending on D, there are two options only, so these two can't be the answer. It must start who is having maximum power. Naughty Salman created scene. Naughty Salman created scene in Rancho's car. So this is having maximum minus I, starting with A, So this first is the answer. How many of you got it before? Oh my God, you have done it earlier. Your speed is better than Baba's speed. Oh, great. Now, kids, basic strength. Are you ready for the basic strength? Everyone, are you ready, kids? Everyone. Fifth application. Carbocation stability, carbon ion stability, free radical stability, acidic strength. 4 applications we have done. Now, fifth application. Fifth application. What's that? What's that, kids? Fifth application. Tell me what's that? Basic strength. Basic strength. Now see, if I talk about basic strength, kids, remember that there is nitrogen and it is having lone pair. Now proton will come from acid, proton will come from acid. You kids are in need of government seat and proton is in need of electron. Why it is called as proton? Whereas there is no electron. So it will attack on the lone pair of nitrogen, and after attacking it will gain one electron and they will form a bond. That means the situation will be like this. Nitrogen lone pair has gone to this proton. Now nitrogen got plus charge. This was base, and base got converted into what? Conjugate acid. Now if this conjugate acid is feeling good, hey, wow, hydrogen, you are loving me, you are good, wow, I'm so happy once I got it, now don't go away. So he is feeling good, so he will not go back. And if this nitrogen is not feeling good, not feeling stable, then it will come back. So that's why organic acids as well as organic bases are weak. If anyone is going to ask, hey, what will you say about organic acids? They are weak acids or strong acids? Weak acids. What will you say about organic bases? They are weak bases. Organic acids, organic bases, they are always weak. So this is conjugate acid. So as basic strength is directly proportional to stability of, complete the sentence, stability of what? Stability of conjugate acid. Now this is having plus charge. Plus charge means who is the friend of plus charge? Plus I or minus I? Who is the friend of plus charge? Plus I or minus I? Definitely plus charge friend is plus I. So remember that what I'm going to tell you, kids, that basic strength of amines is directly proportional to plus I and inversely proportional to minus I. Why I have written like that? Why it has been written like that, kids? Why it has been written like that? Because we know very well that basic strength is directly proportional to stability of conjugate base and conjugate acid. And what's a conjugate acid? Conjugate acid is nitrogen with a plus charge. Now, who is the friend of plus charge? Plus charge friend is plus I. My dear Kutti Chetan, my dear friend, who is your friend? Whatever, right? Now, one more thing I would like to say, that basic strength is directly proportional to Kb value and inversely proportional to pKb value, right? Just like acidic strength. This you will study in ionic equilibrium. If this much is clear, my dear friends, I would like to tell you one thing, that once somebody is flying airplane, they have just to have knowledge of how to fly it. But somebody is moving on the road, do you think that you should have only the knowledge of how to drive, or you should have number of other knowledges? There is something, some bicycle one is coming, oh, from the front truck one is coming, boom, 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 boom. Somebody is coming like that. We should know number of. Champa is coming. Hey, Champa is coming. Ta ta ta. So once you are on road, you should have number of things in your brain. Somebody is coming from right, left, front. They are going to hit you, and they will say, hey, what are you doing? You should know how to apply brake also. Yeah, very good. Somebody has really written very good thing. You should know how to apply brake, because number of times. Now, once we are going to talk about basic strength, then remember that they will ask you basic strength in gaseous form and basic strength in aqueous form. There are two types of questions. Sharmila, thank you, Sharmila. Oh, Champa will come. Champa is coming very soon. Champa was on vacation. Now Champa has taken some break. Now Champa will come. Champa is coming, kids. Champa is coming speedily. Hey, Champa, everyone. Champa is coming now. Now see, kids. Now remember that basic strength in gaseous state, basic strength of amines in gaseous state is directly proportional to plus I, nothing else. Directly proportional to plus I and inversely proportional to minus I. That's it. Nothing we have to see. Nothing more is required. So I can say trimethylamine is maximum basic, 3-degree amine, then 2-degree amine, then 1-degree amine, and definitely ammonia. Now kids, I want to mention one point. Should I mention one point, kids? I don't know how you are going to take that point. I don't know how you are going to take that point, but I have to mention it. Should I? Kids say, should I mention it? Gaseous state. This is gaseous state. Now kids, we know that right now I'm teaching you basics. After this I will teach you hyperconjugation. And then I will tell you resonance and its application. The most important thing whenever I'm going to tell you resonance and its application, that will include inductive effect as well as hyperconjugation and then resonance. And those questions will be really awesome. Now, as the time is increasing, the quality questions will increase, but the live viewers decrease. I don't know why, kids. As the time getting increased, the quality of concept and questions will increase, but viewers are going to get decrease. What is this? Which fundamental? You don't want to become doctor. You don't want to become good engineer. I don't know. I can't understand. You kids are not having brain, kids. I can't understand why this is why this happening, and every lecture, in every teacher's lecture this happens. I don't know. Otherwise there should be, if the knowledge gaining questions are increasing, strength should increase. After 12 minutes I will give one break. After 12 minutes. After 12 minutes. Okay. Now see kids, in aqueous state, remember that if they are writing aqueous state, or if the state is aqueous, spelling is wrong, I think. They are writing aqueous state, or if state is not mentioned, or if state is not mentioned, then automatically take it, then also take it what? Then also consider it aqueous. Now, then basic strength depends on three factors. Then basic strength depends on, kids, three factors. Depends on three factors. What are these three factors? Let's see, kids. First, inductive effect. Second, steric factor, as I've told you in the starting. Third, hydration energy. That means by combining all these three factors, the effect will come out experimentally, and we have to cram it. Experimental data will come out, will give the answer, and we are supposed to cram it. So what is that experimental data? I'm going to write down, and we have to cram it. We have to cram it, and then I will tell you which factor is giving vote to which thing, right kids? See kids, everyone, what the order has come out, experimentally determined. Order has been determined experimentally, has been determined experimentally. Now see what's that order, kids. Remember that, kids. 2 degree, 3 degree, then ammonia. But this is valid only when R is what? If R is methyl. Remember that if R is methyl, then this is the order. If R is ethyl, then the order will be 2 degree, then 3 degree, then 1 degree, then ammonia. This will be the order if R is ethyl. Now, my dear students, how to remember it? How will you remember it? Just see. This is one order. This is another one order. How to keep it in your hippocampus? For that, see. This number and this number is same in both. This number and this number is same. Ammonia and ammonia is same. Where is the difference, kids? Where is the difference? Difference is over here, over here. This is 13 number, this is 31 number. Remember that methyl is small. Methyl is small and ethyl is large. So for small, the number is smaller. For small, this is small, the number is small. This is big, so number is big. Can you keep it in your brain, kids? Now, if this question is coming in your examination, can you answer it, kids? Tell me, kids. Now, who has given both to whom? Let me tell you this, then I will give you a break. I promise. God promise, kids. Let me explain this. Then I will give you one break, okay? Right, kids? Now see, kids. Inductive effect says, if you follow me, my vote is maximum to 3 degree, then 2 degree, then 1 degree, then ammonia. Now, in the picture, Champa has come. Champa's asking, oh, Mr. HSP, you are saying like this. On what behalf you are talking like this? My assistant, Champa. Those who are interacting with the Champa for the first time, let me tell you, Champa is my assistant. Now, Champa is asking, hey, HSP. She talks like this. Hey, HSP, on what behalf? You're talking like this. Oh, Champa dear, let me explain. Nitrogen, if nitrogen is attached with 3 methyls, all 3 methyls, what they will do? All 3 methyls, they will donate electron to this nitrogen. They will donate electron to nitrogen. Now, nitrogen will become maximum electron rich. Nitrogen is maximum electron rich. Now, the maximum electron rich, we will say this nitrogen is having maximum electron density. Nitrogen is having maximum electron density. So most easily this nitrogen can donate its lone pair to proton. Most easily it can donate electron. Now, if you want to see this from other side, you can also see. Let me tell you. After gaining proton, how it will look like? How it will look like? After gaining proton, if once the proton is going to attack, it will look like this. Now, I've told you, If somebody is having plus charge, who is the friend? For plus charge, plus I is the friend. So all they are donating electron, all they are having plus I. There are 4 plus I. So charge will be maximum disperse. Maximum dispersal of charge. Maximum dispersal of charge means, this means least is the charge, least charge. In the starting I have told you charge is like disease. Least charge means most stable conjugate acid. Most stable conjugate acid means most acidic base. This is most stable. Once this is most stable, that means this is most basic. Most basic. But this is only the one point. When somebody is in the water, there are a number of the other things. Steric factor, hydration energy, 2 more points are there. Let's see what they are saying. This is just like, there are 3, suppose if I say in India there are 3 parties. One is Majapa, one is Bongres, one is Sap. I have changed the name. Now somebody, Champa is saying, I will give vote to Majapa. Pandu is saying, no, I don't like that party. I will give my vote to MAP. Now Ramu has come. Ramu is saying, no, where should I give my vote? My vote is hidden. Now which party is going to win? Can you tell? We can't say. Only the results will speak. That is experimentally determined. Once there are 3 parties, oh Kashi, thank you kids, thank you Kashi. Kashi is saying you are the best teacher. Oh my God, thank you. Ramu versus Champa. Wow, thank you, really thanks. Kids, really you are loving this, my lecture kids. Thank you. Now see, so inductive effect says my vote is maximum for plus I. Let's see what other says. Let's see what other says. Steric factor says, the second point. Steric factor says my vote is maximum for ammonia. According to me, ammonia should be most basic. Now Champa has come into the picture. Hey, HSP, explain this. Champa is asking. Champa is always asking questions. Champa is saying, hey HSP, answer this question. Hey Champa, how I can answer this question? Let's see. Kashim, thank you. Mobin Kashim, thank you. Champa Bhabi, okay. I told you I will give break at 8, but let me complete this basic strength. Then definitely I will give break. Let me complete basic strength. So inductive effect and its applications will be done and dusted. Then after the break, we will start with hyperconjugation. We will start with hyperconjugation, right? Kids, please, just 10 minutes more. 10 minutes more. Definitely I will give break. Now, steric factor says, see, this is nitrogen. These are smaller hydrogens. And proton can come and attack on this nitrogen. It's a easy kill. This lone pair is easy kill for hydrogen. Easy attack. But if you consider this 3-degree amine, nitrogen, carbon, hydrogen, 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 carbon, hydrogen, 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 carbon, hydrogen, hydrogen, hydrogen. Can you see one thing, kids? These hydrogens, these carbons, they will occupy space. Once they are occupying space, now whose lone pair is easy kill? For proton. Proton can attack on this lone pair easily, or proton can attack on this lone pair easily. Ting, 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 oh, which is easy kill. Which lone pair is easy kill? Do let me know. Now this is easy kill. This is easy kill. So this is most basic. According to steric factor, this is most basic. Let me tell you kids, in your life, day-to-day life, if somebody is selling sweets, Mysore Pak, if somebody is selling sweets, Mysore Pak, then do you think the one whose Mysore Pak is very, very costly and very, very high quality, that Mysore Pak, people are Mysore Pak, people are buying that Mysore Pak, or the one who is selling not that quality Mysore Pak, people will go to that shop. So answer is people will go to both the two shops. One is overcrowded because its Mysore Pak is really the fantastic, awesome. So there will be too much crowd. So some people will say, oh, here is too much crowd. Let's go and somewhere else we will buy it. And we have to give it to some relationship only. Somebody's aunt house or somebody's house they are going. Let's take it from this shop because no crowd is there. So everyone's Mysore Pak, everyone is able to get it. Are you getting my point, kids? Now, kids, steric factor is saying like this. Okay, let me tell you what. Thank you. Let me tell you what water says, then I will give break. Okay, I will not complete basic strength. I will tell you basic strength, but let me tell you what water is saying. Please consider water, then I will give one break. Okay, what hydration energy, third factor. Third factor is hydration energy. Before I tell you hydration energy, what do you mean by hydration energy, kids? If you don't know, then I will tell you, don't worry. Let me show you hydration energy. So let us suppose there is one jar or one beaker or one flask, whatever you can consider, there is water. There is water. And ammonia has gone inside the water. Hey, I have come over here. Now let me consider another one jar, and there 3-degree amine has gone. There is water. There's lovely water. The water is blue, and 3-degree amine has gone inside it. Let's see what is going to happen. This is ammonia and that is 3-degree amine. Water will say, hey ammonia, I love you. Now what he will do, water will do, see, ammonia, water will behave as acid, otherwise water is amphoteric, and this is base. Now water will give proton, will donate proton, and this ammonia will become ammonium, and water will become OH negative. Now what is going to happen? Water will come near to this ammonium and will surround this ammonium from all the 4 sides, and water will say, hey, I will form intermolecular hydrogen bond with you, intermolecular hydrogen bond with you, intermolecular hydrogen bond with you. How many hydrogen bondings are there, kids? How many hydrogen bondings are there? 4 intermolecular hydrogen bondings. And whenever hydrogen bonding is getting formed, molecules are coming nearer, energy will get released, maximum energy will get released. So delta H will be maximum negative, and whenever delta H, this is only hydration energy. So you know that delta G is equal to delta H minus T delta S, gives Helmholtz equation. More is negative delta G, most forward direction reaction it will go, and there water will react and it will convert like this Now tell me kids, how many hydrogens are there? There is just one hydrogen, so only one intermolecular hydrogen bonding. Only one intermolecular hydrogen bonding. So remember that. It's over and out, just 30 seconds. After 30 seconds, I'm going to give you a break. I'm going to give you one break. It's after 30 seconds, just wait and watch. So hydration energy says my vote is maximum for ammonia. This is most basic, then 1 degree amine, then 2 degree amine, and then 3 degree amine. According to me, this should be the order, because after going inside the water, it will become NH4 plus and it will form 4 intermolecular hydrogen bonds. It will become R NH3 plus, it will become R2 and H2 plus, and this will become R3 and positive H. So 4, 3, 2, 1. More the intermolecular hydrogen bonding, more will be the energy release. So hydration energy will be He will be maximum for this. This will be most basic. Now let's meet after 40 minutes. What's the time right now? 20:10 at 40. So we will meet at 8:50. Okay? Yeah, 8:50. Come with positive energy, lot of positive energy kits. Will you come at 8:50 with positive energy kits? Do let me know. Dinner break. Let's meet at with lot of ATPs. Make a promise that you will come with lot of energy kits, lot of ATPs. Okay, let's see with how much positive energy you will come, kids. Welcome back, kids. I want to see some fire in the chat section. If you're ready, kids. Where am I? Yeah, Baba is over here, kids. Kids, how do you manage? How do you manage that you are going to watch each and everything, each and every concept you are going to watch, kids? How do you manage? From where you people are getting energy that yes, you will remain up to the last. You are going to watch each and everything. You are going to do all the questions. How do you manage, kids? From where you are getting that much of energy? Now, once again, do let me know that. Am I perfectly audible and visible to all of you? If yes, then I want to see some fire or green hearts. Everyone, just do let me know. Your Baba HSP is visible, perfectly audible to all of you or not? Yes, I will tell you each and everything, all the concepts once they are getting over. So, everyone ready? Yeah, somebody is writing in your toothpaste, namak hai ki nahi hai, like that. Yeah, thank you, kids. Thank you. Now, how many of you will remain up to the last? That the resonance application, once the application of resonance is going to come, that aromaticity, anti-aromaticity, once again the carbocation stability, carbon stability, free radical, and basic strength, acidic strength, that is the resonance. Once the resonance is going to come, you will feel that it's really mind-blowing. Now, hyperconjugation is also really something to say that yes, it's mind-blowing. These all things holds a hell of a lot of weightage. What I want to say that, what I want to convey the message that is really, as we are moving towards the resonance, the level up, the questions, each and everything, you will say, yes, it's awesome. It's awesome. Class duration of that, I don't know. I have to complete hyperconjugation, then application of hyperconjugation, then resonance and application. That's it. But it will take too much time. Kids, it is going to take too much time because all these things holds a hell lot of weightage. So, ready? Let's it go. Okay. Now, kids, the basic strength. Let me tell you the basic strength. And basic strength, only one thing you have to keep it in your brain about the basic strength, that basic strength of amines is directly proportional to plus I and inversely proportional to minus I. That's it. Only this much you have to keep it in your brain, then you can do all the questions. If you remember this thing, then no one can beat you. Now see, kids, question. If I say that I'm being provided a compound A like CH3, CH2, NH2, B is CH2, double bond CH, NH2, and C is CH, triple bond C, NH2. Now, it's very common thing that all the three are NH2. But if I talk about this carbon's electronegativity is 2.5, 2.75, and this is 3.25. So definitely this is least electronegative. So it will donate electron because it is 3, it is 3, it is 3. This will donate maximum electron, this will donate less, and this though electron withdrawing because this carbon is more electronegative than nitrogen. Now people will say, hey sir, I to never heard like that, nitrogen and carbon, how carbon can be more electronegative than nitrogen? Kids, remember that this is sp hybridized carbon that is more electronegative than nitrogen. So now the answer is very clear This is the basic strength. This is the basic strength. I think I made myself very clear. This is the basic strength. Now, at the same time, if the question would have been last like this, that one is CH3, CH2, NH2. One is CH3, CH, double bond NH, and one is CH3, C triple bond N. Now kids, just try to understand these nitrogens are not similar. What I want to tell you, this nitrogen is having one lone pair and three sigma bonds. So what are you talking about? Steric number, sigma bonds plus lone pair. It is having one lone pair and three sigma bonds. 3 plus 1 is 4. 4 means sp3 hybridized. Now here you see one lone pair, one sigma and one sigma. Steric number is 2 plus 1 is 3. It is sp2 hybridized. Now here one sigma, one lone pair. So steric number is 1 plus 1, 2. It is sp. Now what you will say? Which nitrogen is maximum electronegative? So remember that. Remember, my dear students, remember this. Electronegativity of central atom. Electronegativity of central atoms directly proportional to percentage of S character. Percentage of S character. So it is having how much S character? If I am having pizza and if I divide the pizza in two parts, so 1P1 has 50% S character. Here pizza is divided into three parts, so 33.33% S character. Here pizza is divided into four parts, so 25%. This is most electronegative nitrogen. So definitely the basic strength will be in this order. I hope that I made myself very clear. If everyone got it, then green hearts. One more question I will deal with, and then I will move towards hyperconjugation. Now question has been provided like A, like this, B, C, now most basic, definitely you can answer it. Plus I from both the side. This is most electron rich, minus I, and this is distance is too much near. So the basic strength is in this order. I hope it's clear to all of you. Basic strength. Now basic strength is done and dusted. Now we are reaching towards hyperconjugation. Everyone, are you ready? Fire, symbol along with fire and green hearts. Hyperconjugation. We are moving towards the world of hyperconjugation. Hey, hey, hey. Hey, 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 everyone. Hyperconjugation. La 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 la. We are moving to the world of hyperconjugation. Hyperconjugation, which holds a whole lot of weightage. Remember that. It's very, very important, kids. Everyone, do let me know. Is everyone ready for the hyperconjugation? Let's welcome to the world of hyperconjugation. Hey, hey, everyone. If you are able to understand this hyperconjugation, you will say, wow, sir, it's really awesome. Hyperconjugation. the only nation, hyperconjugation, the only nation, hyperconjugation. Let me make number of copies so that we can understand in detail. As the time passing, the level will increase. Level will increase. Remember that level is going to level up. Yeah, we will do P by Q's number of questions. Don't worry. Now, hyperconjugation's another name is no bond resonance. First C, no bond resonance. They can ask what are the names and I will explain each and everything. No bond resonance. Hyperconjugation is also known as sigma pi conjugation. Sigma pi conjugation. This is also known as sigma bond resonance. Sigma bond resonance. This is also known as Baker and Nathan effect. Baker and Nathan effect. Now, all the things, they are having their meanings. All these words, they are having their meanings. So, remember that no bond resonance, sigma pi conjugation, sigma bond resonance, Baker and Nathan effect, they all are having their meanings. Why the names they have kept like this? They all are having meanings, right? Try to dissolve in your blood. Okay, what's the name and what's the meaning? Once I'm going to explain, everyone will be able to understand, and this is very, very important, right? Now, let me start. Now, kids, first of all, I will tell you hyperconjugation in alkene, right? Hyperconjugation in alkene. You must have studied that stability of alkene. Stability of alkene is directly proportional to number of alpha hydrogen, but you never think about, you are never going to think about that why stability of alkene is directly proportional to number of alpha hydrogen. Once I write down stability of alkene is directly proportional to number of alpha hydrogen atoms, right? What question arises? Why? What's the reason why it is like this? Have you ever thought? Have you ever thought why the stability of alkene is directly proportional to the number of alpha hydrogen? How hyperconjugation is going to take place in alkene? What's the reason behind it? Now, see kids, see to it. If I say, when we were in class 10th, we have seen propene. Have you seen propene? We saw propene like this. Some of you must have seen propene like this. Then you grown up, then you started seeing propene like this in your class 11th standard. This is 10th standard, this is 11th standard. Now, if you want to get success in your examination, competitive examination, never see propene like this. If you're thinking propene is like this, you are not intelligent. You are going to fail. You won't be able to get full marks. You won't be able to get government seat. Then how to see propene? See. Just for few seconds, your HSP Baba is a painter. Let us think that your HSP is a painter HSP, right? I will not say anything, just try to understand. Just for few seconds, your Baba has become painter. I'm not your Baba, I'm a painter. Who is the best painter? Who's the best painter? I'm trying to be like him. Can you see? This is my painting. What you can see? Have you seen my painting? Have you seen Da Vinci? Oh, Da Vinci. Okay. Have you seen my painting? What you're getting? Now just try to see. I would like to say this is sp2 hybridized carbon atom. Now let me apply signs sp2. This is sp2. The atoms which are directly attached to sp2 hybridized, they are known as vinylic atoms. Which atoms? Say everyone. Vinylic atoms. Everyone say vinylic atoms. And these which are attached on sp3 hybridized, which is adjacent to this olefinic. Olefinic means double bond. Olefinic means carbon-carbon double bond. Olefinic bond. So these are known as allylic. What I'm saying? Allylic, 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 allylic atoms. Allylic atoms. Some people also say this is alpha carbon, so these are alpha hydrogen atoms, right kids? This is the knowledge we are going to get, kids. This is the knowledge we are going to gain. Now, my dear students, what you see that these are stronger bonds. Vinylic atoms, they are strongly bonded. Can I say like this? Are you going to get from the painting? From the painting, what knowledge you are going to gain? That these are strongly bonded. Are you getting my point? These are strongly bonded. And these are loosely bonded, loosely bonded. Are you getting this point, kids? Everyone, just do let me know in the chat section if you are getting it. Loosely bonded, loosely bonded. Loosely bonded, loosely bonded. Everyone. From this, the Vinci picture is explaining like this. The Vinci picture is talking these things that yes, these are loosely bonded and these are being strongly bonded. Are you getting my point? Now on the next page, I will show you. Okay, let's see. Now I'm going to move on the next page. I'm going to move on the next page. Are you ready? Kids, are you ready? Everyone is ready. You are with me or not? Now see, kids. This is carbon-carbon double bond. I can write R, anything, anything. It can be here. And I need just one alpha hydrogen. Whatever it's over here, it's okay. Now see, this is pi bond. This is pi bond. Okay. There are two theories. One is valence bond theory and second is molecular orbital theory. If the NTA is giving tough question, they will move with the molecular orbital theory, right? So let me give you the clear picture. Now see, this is a pi bond. Are you getting my point? This is a pi bond. This bond is being pi bond. Actually, it is a boundary surface diagram. If you see, it's not a pi bond, it's a boundary surface diagram. Boundary surface diagram. If you know atomic structure, it's a boundary surface diagram. And if you go away from it, if you move away from it, now it will become orbital, pure p orbital. Now the bonding, slight bonding is pi bond. This is pi bond. This is pi bond. Now pi bond is there. Pi bond is there. So you know that pi bond is there. So pi anti-bonding will be also there. Pi anti-bonding molecular orbital, ABMO, anti-bonding molecular orbital, which is being empty. This is filled with electron. This is so filled. Try to understand, because if examiner is going to give you tough question, they will ask each and everything. Now this is sigma bond, but this is a weak bond. This is a weak bond. So its electron will definitely move like this, and it will touch. So they are moving over the sigma bonded electron. Sigma bonded electron is going to not to pi anti bonding. This is empty, this is vacant. This is able to accept electrons. So actually sigma bonded electrons are moving to pi star. Pi star means anti-bonding molecular orbital. Anti-bonding molecular orbital. Anti-bonding molecular orbital. So examiner will ask in alkene what's happening. Tough question if it is coming. They will ask that sigma bonded electrons, sigma bonding molecular orbital electrons moves to pi anti-bonding. But generally valence bond theory, if I talk about valence bond theory, people will show you like this. See how people will show it like. People will show you like this, and we are able to understand easily. See, in generally books, it's written like this. In most of the low standard books, it's written like this. This bond will break, sigma bond will break. Sigma bond will break. It will move out, and see it will. No. I have written one carbon less. Let me write down. One more carbon will be there, kids. So the sigma bonded carbon's electronegativity is 2.5, hydrogen is 2.2. So electron will come over here. This will develop partial negative. This will develop partial positive. Now what is going to happen? This carbon will develop negative charge. Now what will happen? Now this electron will come over here. This electron will come over here. It is having 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. So this electron will go over there from here to here and here to here. What is going to happen? See, this carbon will develop double bond, and this carbon will have negative charge like this. Now they will write down a true structure for this. They will write down a true structure for this. So carbon and hydrogen delta positive, partial negative, like this. Carbon R, so somewhat double bond, and here more double bond character like this. So this is also a little bit, I would like to say, correct now. And here also somewhat negative charge. So this is a true hyperconjugative structure, and I would like to say it is giving clear picture. Now see the difference. Those who don't know, those who are not having knowledge of hyperconjugation, they will say this is pure sigma bond, and they will say this is pure pi bond. But those who are having clear knowledge, they will say there is no pure sigma, no pure pi bond, because this double bond is having a little bit, double bond has developed partial single bond character, and single bond has developed partial double bond character. Are you getting what I have written? If you keep your doggy with human beings, a doggy will acquire somewhat human beings character, not proper, but little bit. And if a human being, suppose Champa is going to the jungle and Champa has spent 10 years in the jungle, so Champa will develop some Mowgli character. Am I right or wrong? Champa will develop, Chaitanya, welcome Chaitanya. Champa will develop a little bit doggy character, Mowgli character. Are you getting my point or not? So during hyperconjugation, single bond develops partial double bond character and double bond develops partial single bond character. Now, how it is going to affect? How the question will come? See how the question can be asked. Sequence. If I say that CH2 double bond CH2, have you seen ethene? No alpha hydrogen, no hyperconjugation. No alpha hydrogen, so no hyperconjugation. Am I right? There is no hyperconjugation. No alpha hydrogen, so there is no hyperconjugation. So this bond length is 1.34 angstrom, and this is pure double bond. Remember that. This bond length, you have to keep it in your brain. You have to dissolve it in your blood so that it should become a reflex action. Now, if I say at the same time, this is your ethane. Now, no hyperconjugation. So I would like to say this bond length is 1.54 angstrom. Pure double bond, pure single bond. Are you getting my point? Pure single bond. This is pure double bond. But see how the question will be asked, how the question will come in your examination. Question. Compare the bond length. Compare the bond length and write in decreasing order. Now compound is given like this: CH3, CH2, CH double bond CH, CH3, CH3, CH double bond CH2, right? Now this is A, B, C and D. Now tell me which bond will have maximum bond length? Which will have maximum? Which will have maximum bond length? Wow, thank you, Akashpati. Thank you, Akashpati. Now tell me fast in the chat section. Do let me know which bond will have maximum bond length. A. Yes, very good. This is pure 1.54 angstrom. Pure single bond. Then after A, on second number B. B, yeah, somewhat less than 1.54, I don't know, 1.53 angstrom or 1.52, that I don't know, but somewhat less than 1.54 angstrom. Now this C will be a little bit more than 1.34, so I can say 1.35 angstrom or 1.36, I don't know. So A, then B, then C, and it is pure, no hyperconjugation, so it is 1.34 angstrom. So after that D. Now kids, they haven't asked what is the bond length, but we can compare. Everyone got it? Is it clear, kids? The bond length, how the question will come, how the question will be asked. If this is clear, show me green hearts. Those who got it, those who are able to understand, I want to see green hearts in the chat section, kids. Everyone. Very good, very good. That's fantastic. Now, the question arises that how the stability will increase, how the stability will increase. The second question will come like this. Compare the stability. Compare the stability of following alkenes. Compare the stability of following alkenes. Let's see what's the compound. A is CH2 double bond CH, CH2, 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 CH3. B is CH3, CH double bond CH, CH2, CH2, CH3. C is CH3, CH3, C double bond CH, CH2 and CH3. And the last one, but not the least one, CH3, CH3, C double bond C, CH3 and CH3. So it's very easy to give the answer, but to understand how the stability is going to increase, that's a real gem question. Now see, kids, everyone, how to find out alpha hydrogen. See, this carbon is double bonded, this carbon is double bonded. Okay, just see, those who are not able to understand, let me tell you. So enclose it, double bonded carbon. Now just the adjacent one. Okay, let me first write down everywhere so that our time gets saved, right? Now just try to find out alpha hydrogen. Put all the efforts to find out alpha hydrogen. Double bonded carbon. Next carbon, this is alpha carbon, and how many alpha hydrogens are there? 2 alpha hydrogen atoms. Now see, this is double bonded carbon sp2, this is the alpha carbon, 3 alpha hydrogens, 3 alpha hydrogens, and this is also 3. 3 plus 2 is how much? 5 alpha hydrogen atoms. Now see, double bonded carbon, this is directly attached, this is directly attached. So 3 and 3, 6 and 2. So 3 plus 2 is 8 alpha hydrogen atoms. Now see, these three, these three, these three, these three. 3 into 4, 12 alpha hydrogen atoms. So answer is very clear that more the number of alpha hydrogen atoms, more is the stability of alkene. So the alkene stability is moving in this way. I hope that it's clear to each and everyone. But question arises, how? That is the $1,000,000 question. Now see the $1,000,000 question. Let me write down the stability. D is more stable than C, then B, then A. Let's compare. See, kids, let's compare. If I say, who is making this compound to be unstable? Who is making this compound to be unstable? Definitely these electrons are there. So it's a nucleophile. Nucleophile means electron rich. So electrophile will come. And let me say this is a rabbit. If you say this pi electron is being rabbit. And if I say electrophile is an eagle, it's an eagle. So for eagle to attack on this lone pair, or the rabbit can't move. This rabbit can't move because there is no alpha hydrogen. So can't move. This rabbit can't move. Who is the rabbit? The pi electron. Why it cannot move? because adjacent to it there is no alpha hydrogen, so no pure p orbital, so it cannot move so easily. It will attack easily and this compound will lose its identity. This compound will easily lose its identity and it will easily change into a compound like this. Easy. Now if I say at the same time I am having a compound like this, now do you think rabbit is fixed or rabbit will move? See, we are having 3, 3, 3, 3. So 12 times this pi electron will move. Too much area is there for this rabbit to move. So the rabbit will move very speedily to any place and the rabbit can hide into this much area. This rabbit is having this much area to get delocalized. This rabbit will move here and there. This rabbit will move, but this rabbit was unable to move. Its area was just this much. It has to spend its time at this particular area. Which rabbit is easy? This rabbit is delocalizing, doing hyperconjugation in this much of area. So do you think that eagle can easily attack on this? Eagle can't attack easily. It will take too much time. So this compound's identity will be there. Got it? Those who got it clearly, I want to see green heart skits. Now, let me tell you hyperconjugation in what? In carbocations. Let me tell you hyperconjugation in carbocations. Champa, what are you doing, Champa? Wow, Champa, nice handwriting. Hey, Champa, really, you are doing a great job, Champa. Wow. I am not doing anything. This all things are done by Champa only. One boy is writing, one boy or girl, I don't know. Something he or she was writing, I have seen that. Okay, anyways. Now, hyperconjugation in carbocation. Are you ready for that? Everyone? In carbocation. Now, once again, stability is directly proportional to number of alpha hydrogen. Let's see what happens over here. If I write here is plus charge and there is alpha hydrogen, what do you understand by this? We know that one thing is valence bond theory, another one is molecular orbital theory. First, let me tell you through valence bond theory. See kids, this carbon's electronegativity is 2.75 and this is 2.5. That is more electronegative carbon, right? This is more electronegative carbon, kids. So it will try to withdraw electron from here and this bond will break. this will develop partial negative, and this will develop partial positive. So right now I am dealing with valence bond theory. Valence bond theory looks very simple, but remember that the exact idea and the correct approach we are getting only from molecular orbital theory. Valence bond theory is not giving the correct approach. Now see, this bond will break, and how it will look like? It will look like this. Now what is going to happen? What is going to happen? It is having 6 electrons only, and it is having 8 electrons, and they will form a bond. Now both of them will have 8 electrons. Got it? Their octet got complete. Their octet got complete. Now let me deal with the molecular orbital theory. Actual idea is given by molecular orbital theory. Valence bond theory is not giving that great idea which is given by molecular orbital theory. See the molecular orbital approach. MOT approach. C plus CH. This is plus charge, so pure p orbital is there. Pure p orbital means with 2 lobes, and these 2 lobes are like this, and this is vacant orbital. Vacant. What do you call it? Bonding or anti-bonding, or pure p orbital. So remember that it's pure p orbital. What is the name of it? This is pure p orbital. What do you mean by pure p orbital? Because in assertion and reasoning they can give you any question, so we have to get command on this. Pure p orbital means unhybridized orbital. It is filled with electron or empty. Remember that this is having 2 electrons, this is having 2 electrons, this is having 2 electrons. So carbon is with 6 electrons only. So this orbital is empty or vacant orbital. So my dear friends, this sigma bonded electrons will go into pure p orbital. That's it. The toughest question will come like this. Sigma bond electron will shift to pure p orbital. That's it. Either you cram it or you understand it. In alkenes, sigma bonded electrons have been transferred into pi anti-bonding molecular orbital. Here sigma bonded electrons are going to pure p orbital. Got it? Everyone got it? Now that's it. Now let's see in the free radical, but here the stability, let's see that carbocation stability is directly proportional to number of alpha hydrogen atoms. Now question arises, kids, that if I am having this carbocation, and sir you said that this hydrogen will participate, because for forming bond, the pi bond formation, they should lie parallel to each other. So this electron can migrate. But sir, what's about these 3 hydrogens? If I place these 2 more hydrogens, then do you think, sir, they are going to participate? Yes. How they will participate, sir? How they will participate, kids? Remember that this is single bond. Sorry. This is a single bond. And if you have gone through conformational isomerism, this is a single bond. This is a single bond. And single bond can do free rotation. Can do free rotation. There is free rotation. So free rotation is there. That means once it will come over here, once it will come over here. So all X, Y and Z, one by one, they will participate. Now, this is clear. All the bonds will do free rotation. This is single bond, so free rotation is possible. They will do one by one. They will form a bond with this. Now, next question, that how many hyperconjugative structures will be there? The number of hyperconjugative structures are equal to number of alpha hydrogen or plus 1. Are you getting my question? That how many hyperconjugative structures will be there? Number of, if they are asking this question has been asked in IIT 2009. 50% coaching, they have given answer, number of hyperconjugative structures are equal to number of alpha hydrogen. Rest of 50% coaching, they have given answer that whatever the number of alpha hydrogens are there, plus 1 more means. Which should be the correct? Let's see. Plus 1. Very good. Who has written? Oh, Harni, Akash Bhatti. Wow, you are genius, kids. Genius. Number of hyperconjugative structures is equal to number of alpha hydrogen plus 1. Why, kids? Suppose if I say this is Champa and Champa says I have 3 sisters. Champa is saying I am having 3 sisters. So tell me how many sisters are there? If Champa is saying I am having 3 sisters, Champa is saying like this, I am having 3 sisters. So total sisters are there. Tell me the number of sisters, total number of sisters. Hey kids. Champa is saying I have 3 sisters. So total sisters, kids, total sisters will be 1 Champa plus 3 more, total 4 sisters. Am I right? Now, how it is valid in chemistry? First of all, do let me know this is clear. Yes, sir, this is clear. Champa, is it clear to you? Yes, sir. This is very much clear. Okay, Champa. Now, Champa, see, Champa is asking, tell me in chemistry, sir. Okay. Now, if I say that I am having one compound like this, oh, carbocation, it is having just 1 alpha hydrogen. If I say 1 alpha hydrogen atom, so if it is moving like this, another hyperconjugative structure will be like this. Hydrogen will come over here. So total how many? 1 alpha hydrogen. So we are having 2 hyperconjugative structures, right? I hope this is clear. This is very much clear. These are the 2. So always plus 1. Always plus 1. One more will be there, right? Now, in free radical, hyperconjugation in free radical, this is the third one. Now see kids, first I will tell you valence bond theory. VBT means valence bond theory. If I say this is carbon, there is carbon, at least 1 alpha hydrogen should be there. So I would like to say there are 7 electrons and there are 8 electrons. How to count electrons, those who don't know? So 1, 2, 3, 4, 5, 6, 7, 8. Got it? How it is having 7? How it is having 7? 1, 2, 3, 4, 5, 5 and 6 and 1, 7. So free radical will make free radical only. This bond will break through homolysis. Homolysis will be there and it will look like this. Now both the two carbons are having 7 electrons only. So what they will say, I'm having 7, you are having 7, let's come on, make a one bond. We will having 8 and 8. Okay, so nice of you. But if tough question is coming, they will move towards molecular orbital theory. They will ask question from molecular orbital theory. Now let's see if I apply molecular orbital theory in free radical. MOT, molecular orbital theory. Let's see, kids. If I say this is bond and this is at least one alpha hydrogen atom is required. So where it will move? First of all, see the free radicals hybridization is. Just focus. Steric number is 3 sigma bonds, no lone pair. So 3 sp2. sp2 means one orbital is not totally vacant, but it is having one electron. But this is not a hybridized orbital. Remember that. It's not a hybridized. So this is known as SOMO. Say everyone SOMO. What do you mean by SOMO? SOMO means singly occupied molecular orbital. Molecular orbital. Singly occupied molecular orbital. Got it? But remember that it is having one electron only. It is pure p orbital, unhybridized orbital. Remember that it is unhybridized. Pure p orbital, pure p. Pure p means which is not the part of hybridization, pure p orbital. So this sigma bonded electron will go to pure p orbital. This is the question. So sigma bonding molecular orbital electron will shift to p of SOMO. That's the answer. Whatever the toughest question they are going to ask, you can immediately give the answer. Everyone got it? Now I am going to deal with applications of hyperconjugation, and after that we will move with the resonance. Now kids, have some water, keep yourself hydrated. Everyone, you're loving this lecture or not? You're liking this lecture? You're loving? Tell me in the comments. Show me some green hearts, fire symbol. Yes, like make a Diwali. I want to see some fire in the chat section, kids. Do you think Baba is having low energy? Baba's energy is looking down, or Baba is full on charge? Fully charged. Oh, bhai, smash the like button. Make it 500. Don't ask when the session is going to end. My thing is to tell you each and everything in the decent way, in a nice way. Make it 500. Likes, why likes are 494, kids? 6 to go for 500. Let's see, can you make it 500? Oh my God, thank you. Oh, Vyala, thank you. Wonderful lecture, never seen before. Wow, really awesome. So make it 500. Let's see. Champa phase will reveal after 500. Okay. Now let me show you. Champa will come. See. Champa will come in resonance. But let me show you Champa's phase. See, Champa is Webical. She is Champa. Imaginary Champa. These are the legs of Champa. This is the 2 hands, 2 legs. This I will tell you. I will show you Champa I will show you Champa when I'm going to teach resonance. In resonance, Champa will come. Now, have you seen Champa, kids? Thank you, Tanuja. Thank you. Thank you. Have you seen Champa, kids? She is Champa, my assistant. Complete. Done. Thank you, Sai Kumar. Welcome. My assistant Champa is there. Now, kids, deal with this whole session, this whole hell lot of weightage. Let me tell you, kids, really. Sir, you not Tamil. Ya, vanna randa, monu, nale, anche, are, ere, ette, umpad, inge va, ni po, poda. Chemistry pidikara adu kastama, it's romba sulvam. Chemistry, organic chemistry looks like idiyappam, muruku, romba sulvam, meduva. Now, kids, come back. Hyperconjugation applications of hyperconjugation. Now see, kids, the best application will come in the form of question. That heat of hydrogenation. First application I would like to say, heat of hydrogenation, HOH. HOH means heat of hydrogenation. First, try to understand what is the meaning of heat of hydrogenation. If you study thermochemistry, then sir will tell you heat of hydrogenation. That means if I am having a compound like this, now hydrogen will come and adsorption will take place. These hydrogen will combine with this and they are in the surface of nickel, so adsorption, and this compound will become like this. After some time, you will see this compound like this. Now, one pi bond has broken up, one pi bond has been broken up and two new sigma bonds have been formed. What do you think? Some amount of heat energy will be required to break the pi bond, and a lot of amount of energy will get released with the formation of two sigma bonds. So overall energy is released or required? Overall energy is released. So that is known as HOH, and there it is negative, right? This is known as heat of hydrogenation. So what will you say? Heat of hydrogenation is directly proportional to what? Heat of hydrogenation is, remember that heat of hydrogenation is directly proportional to number of olefinic bonds. Olefinic bonds. What do you mean by olefinic bonds? That is number of pi bonds. More the number of pi bonds, more will be heat of hydrogenation. But remember that the second point, if number of pi bonds are equal, then heat of hydrogenation is inversely proportional to stability of alkene. Stability of alkene. But this is the case, and this is valid only in case of same number of pi bonds. And stability of alkene is directly proportional to number of alpha hydrogens. So I would like to say heat of hydrogenation is inversely proportional to number of alpha hydrogen atoms, right? So these are the 2 points, point number 1 and point number 2. Should I give you one question if you are able to understand these 2 points? Remember that the priority In the priority, first we have to see number of pi bonds. If they are equal, then only go for stability, right? Let's see. Arrange question is arrange the following in decreasing order of stability, right? Arrange the following in decreasing order of HOH, heat of hydrogenation, right? This is a question. Now, kids, are you ready to answer this question? Let's see. A is CH2 double bond CH, CH double bond CH2. B is CH2 double bond CH, CH double bond, CH2 CH3. C is CH3 CH double bond CH, CH3. Answer it. Let's see how many of you can do it. Kids, let's see. Kids, do it fast. Let me check it out. Who is going to give the correct answer? Baba is waiting for your answer, kids. Who will have A, B, C? Wow, very good. Rimuru, Sharmila. Wow. Now see, divide and rule. Divide and rule. This is having 2 pi bonds. 1, 2. More pi bonds, more heat of hydrogenation. Got it? More pi bonds. So it will be on number 1. Now these two are having same number of pi bonds. Same pi bonds. Now, if you see that this is having 2 alpha hydrogen atoms and this is having 3 and 3, 6 alpha hydrogen atoms. So its answer is definitely, your answer is correct. A, then B, and then C. Fantastic, kids, fantastic. Everyone got it. This was the first and the most important application. Now, second one is that heat of combustion. Heat of combustion. So heat of combustion, let me tell you, second application. HOC, heat of combustion. In your thermochemistry, you will study the amount of heat released when 1 mole of compound undergoes complete combustion in the presence of excess of oxygen. So, HOH is directly proportional to number of carbon atoms. More the number of carbon atoms, more will be the heat of combustion. But second point is, what's that? HOH, heat of hydrogen, no, sorry, heat of combustion. We are dealing with heat of combustion. HOC is inversely proportional to stability of alkene. But this point is valid only when, yes, tell me when, stability of alkene. If number of carbons are same, number of carbons are same. I hope this point is very much clear to all of you. So I will not give example of it because we have seen in heat of hydrogenation, same thing you have to apply over here. Now third application. Let's see the third application, kids. Orientation. Have you ever heard the word orientation? It's not that orientation which you have seen in your school. No, not that orientation. Ortho, para or meta. Let's see. If I draw one compound like this, This is known as toluene. Toluene. We know that toluene is ortho and para director. What do you mean by ortho and para director? Let me tell you. Try to see, this is alpha hydrogen atom. It will go like this. So carbon will develop negative charge, and once carbon has developed negative charge, just try to see which side electron will move. This carbon is electron rich. So more electron rich carbon will donate its electron to this carbon, and then this electron will shift over here. Now see, you will get negative charge at this place. Now do you think this negative charge will stop, or it will further move? It will move from here to here. It will come over here, so it will go over there. Now you will get one more structure like this. Kids, I think you are getting tired. Are you? Are you getting tired, kids? Now it will come back. Do you think Baba is looking tired? If not, Baba is not looking tired, then why you kids? So see, now it will come back. It will go back. Hey Simon, go back. Ting ting. So you will get 5 hyperconjugative structures in this way. In this way, 5 hyperconjugative structures, but none of them is being the true structure. They all are hyperconjugative structures, and we will get a clear-cut idea only once we know its clear picture. The clear picture of this compound is like this. The true structure is like this. Just see kids. Negative charge came over here, it came over here, it came over here. It was moving like this. Just move here, just move here. Like this, like this, like this. This is known as true structure, or we can say hyperconjugated structure. So negative charge is coming at ortho, para, and at ortho. So it is OP director. The coming electrophile will come and attack on ortho and para. This is clear to all of you kids. Are you watching this concept for the first, or already you know it? Oh my God, kids, everyone, show me some fire if you are having that much of energy. Now see, fourth application. And fourth application, I will tell you something really awesome. Oh my God. Slides are. Now let me take some other. Yeah, this one. This one is looking so nice. Let me change the color so that you will feel wow. You will get wow feeling. Okay, now you are getting wow feeling, kids. Now let me change this color also, so you will get wow feeling. Wow. Now let me write down with different pen, so you will get wow feeling. Keep yourself. Oh my God, it's destroyed. Champa, make it small and fix it over here. Champa, hey Champa, hey Champa. Wow, Champa, you did it. Now which pen should I use? I will use blue one. Now Champa, amazing thing you have done. Very good, Champa. Now kids, we are over here. Now tell me how you're feeling, kids. First of all, do let me know really you are enjoying this lecture. Hey everyone, You have to remain over there. Hey, God, bless these kids, those who are present, with the best strength. Almighty God, I'm asking to you, bless these kids with all happiness and prosperity along with the best strength in the coming examination. So you have to stay. I'm going to tell you resonance, then really you are going to enjoy, kids. Don't leave in between, kids. I'm awake for you. I'm just praying to God to give you best strength. And you have to have full on energy, kids. Now, kids, reverse hyperconjugation. See, reverse hyperconjugation. What I'm going to tell you, kids, what I'm going to tell you, reverse hyperconjugation. Have you ever heard the reverse hyperconjugation? It is indicated by the letter minus H, reverse hyperconjugation, minus H. Now see, kids, if I put 3 chlorines or 3 halogens, any 3 halogens over here. Now I've told you these are allylic. In case of benzene, these are known as benzylic atoms. Say everyone what they are known as? Benzylic. When they are attached with benzene, benzylic. Everyone say benzylic. And they are loosely bonded. But remember that carbon's electronegativity is 2.5, but chlorine's electronegativity is 3. This is more electron rich, so it will take away electron. What's the difference? Can you see? In the previous case, I told you in place of chlorine, there was hydrogen. Hydrogen was less electronegative, so carbon has snatched electron, but this time chlorine is more electronegative. So chlorine will snatch electron, it will develop partial negative and it will develop partial positive. Now the picture got changed. Now this carbon has developed plus charge. Now what it will do? It will give electron to the benzene, or it is going to take electron. Definitely. This plus charge carbon is going to take electron from benzene because it's not having any electron. So of course, why not? It is going to do that. So he is saying that I will take your electrons. So it will develop negative and it will develop positive, positive, negative. So its positive and negative bond formation will take place. And here you got plus charge. Now you know the scene. It will move around like this. 5 resonating structures. So I am going to draw a resonance hybrid or hyperconjugative hybrid. Partial positive, partial positive, partial positive, everywhere partial positive, and there the bond is like this: carbon, chlorine, chlorine, and partial positive. So this ortho and para are comparatively less electron rich because they are having plus charge. So comparatively, who is more electron rich? Do let me know in the chat section. Comparatively, meta is more electron rich. Are you able to understand this point? Comparatively, meta is more electron rich. So it is meta director. The coming electrophile will attack at meta. It is meta director. I hope everyone got it. I hope that everyone got it. This is clear to each and everyone. Done and dusted. Now, I'm going to start with the resonance kits. Have some water. Everyone have some water. Till now, we have completed inductive effect, its application, 5 applications, hyperconjugation and its application. Now the mega one, now the most important one. Have some strength kits. We are going to deal with resonance and its application. Then you will feel really awesome that you have achieved something. I will really feel accomplished with your stupendous performance if you are going to achieve it. Yeah, let me have some water kits. Same for you. Thank you for reminding me. Everyone, mesomeric effect will come in resonance only. Mesomeric effect will come in resonance only. Kids, you have to wake up. You have to remain in this same position with lot of ATPs. Thank you, Sobha. Thank you, Sobha. Really thanks. Anything which you are really getting something new in my lecture? Kids, you can share if you're really getting anything new from this lecture. Anything new, kids? Now, kids, come on, come on, come on, come on. Aisha, come on, everyone, come on. Here is the resonance and its application. New expected questions. Resonance is also known by the name conjugation or delocalization. What is conjugation or delocalization? Can you see the board? Everyone, can you see the board? Everyone, just to let me know, is the board visible to all of you? Resonance is also known as conjugation or delocalization. In the shortcut delocalization, I will use DLC, delocalization, conjugation delocalization. Now see, kids. For resonance, what is required? This is the electron. Champa is now in the picture, but Champa must be free. Free electrons are required. Only remember one thing. I'm telling you each and everything in just the basic format, the fundamental thing I'm telling you. Free electron and adjacent to free electron, there should be pure p orbital. Why I have drawn hands and why I have drawn legs? One orbital, this is imaginary electron. Champa is not electron actually. We have never seen electron, but I have given a shape so that everyone can keep resonance in brain forever, kids, so that you can solve every question. See, Shivansh, welcome, 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 namaste. This is pure p orbital. Pure p orbital means the orbital should not be hybridized. Unhybridized orbital, then unhybridized orbital will have two lobes, equal sized lobes, because once the orbital is going to hybridize, one lobe will become bigger, another one shorter. So Champa will not be able to move. Champa is free electron. So two hands will go from this and two legs will go from this. This is only resonance. This is only resonance, but people are not able to understand this. So I have to tell you in detail, step by step, inch by inch. Okay, are you ready? Now see, kids, let me tell you in detail. Now before moving towards this, let me show you something. Resonance is of three types: one atom resonance, two atom resonance, and mesomeric effect, three or more atoms. Keep it in your brain. Resonances of how many types? Everyone do let me know, kids. Resonances of how many types? Champa was very nice. Kids, how many of you really like Champa? Champa will clear your all concepts. Champa will give a clear picture to your each and everything, kids. Now, resonance is of three types: one atom resonance, two atom resonance, and three atom resonance. Three atom or more atom, that is known as mesomeric effect. Everyone say, do let me know how many types of resonance is there. One atom, two atom. Two atom is known as back bonding, and three atom is known as three or more atom, known as mesomeric effect. Now, what is one atom? One atom resonance is very clear. One atom resonance, already I taught you. Negative charge, it says negative charge is most stable on biggest atom, this already I taught you. Okay, kids, on biggest atom, negative charge is most stable on biggest atom. This is one atom resonance. Now come to back bonding. Kids, in the examination, maximum kids are getting failed because of this back bonding. They don't know what is back bonding. They are not able to apply the back bonding. Back bonding you will study in chemical bonding also, here also. Everyone ready for back bonding? I think kids are getting what to say. Kids, you're losing your energy. What's going on? Everyone, back bonding, two atom resonance. So let me deal with two atom resonance, that is back bonding. Everyone ready? Are you ready, kids? Back bonding. Now, what is required for back bonding, kids? Remember that one donor atom must be attached with the gainer atom. One donor atom, this G is donor atom. This must be attached with the gainer atom. One donor atom must be attached with gainer atom. There should be a friendship between donor and gainer. They should be bonded with sigma bond first. First thing is required, they must be bonded with sigma bond. This is the must condition. They must be bonded with sigma bond. Now, donor atom must have free electron. Free electron to donate. It can be in 2p or it can be in 3p. 2p is the best. Why the best? I will let you know. And the gainer atom can be 2p or 3d or 3p. This is like this. Now, kids, you won't be able to understand who is having free electron and who is having vacant d orbital or p orbital, what is there. So you won't be able to do the question. Now, kids, to understand it, we have to move towards the periodic table. Who can donate electron? Just see who's having this lone pair, means should have lone pair. So let's see, we have to get an idea over here. If I say that I'm having carbon, nitrogen, oxygen, fluorine. Just below carbon, silicon, nitrogen, phosphorus, oxygen, sulfur, fluorine, chlorine, bromine, like this. Now, carbon is having 4 electrons in the valence shell. So it will gain 4 more electrons. So it will form 4 bonds. Carbon will form 4 bonds, so no vacant orbital. No, nitrogen is having how many electrons in the valence shell? 5. So it is in need of 3 only. So definitely it will form a bond like this. It will have always one lone pair. Now oxygen is having 6 electrons. So it will be in need of 2 only. So it will form R2O. So it will always have lone pair. Now fluorine HF like this. So it will always have 3 lone pairs. Got it, kids? Everyone got it? It is always having lone pair. It is always having lone pair. So in the examination, if you're not able to understand, then remember that who are having lone pair. So see, sulfur will have lone pair. Sulfur will always have lone pair. Oxygen will always have lone pair. Nitrogen will always have lone pair. Phosphorus will always have. Halogens will always have. So they will always have lone pair. They will always have lone pair. Sun px. Can you remember? Sun px. Sulfur will always have. Oxygen will always have. Nitrogen will always have. Phosphorus will always have. And halogens will always have. Right? Just like chicken pox, there is sun pox. Sun pox. Tell me sun pox. Abhijit, welcome, welcome, welcome. Now, sun pox. Sun pox will always have lone pair. Now, see kids. If I say that I'm having a question, let me give you a question. How the examiner will give you a question. Which one is more stable? Which one is more stable? This is a question. Which one is more stable? See kids, this is the question, which one is more stable? Now, two options are given over there. A is CF3 plus B is CCl3 plus. Tell me answer in the chats. A or B, which one is more stable? I'm waiting for your answer, kids. Everyone, I'm waiting for your answer. Do let me know, kids. What's your answer? Which one is more stable? Fast, kids, fast. People are going for B, some are going for A. So see, I've told you, never forget BB, BB for back bonding. Some are going for A, some are going for B. This happens, kids. And that's why I'm telling you that maximum students are getting failed in the examination because of this BB, back bonding. Maximum students are getting failed. Now see, what should be the answer? My dear students, I've told you, first always think about resonance, then go for hyperconjugation, and at the last go for inductive effect. But kids, you have studied inductive effect for the first time. So first love is inductive effect. You are always applying inductive effect. Now see kids, CF3, you see carbon is having just 6 electrons in the valence shell. 3 fluorines are they being attached. 3 fluorines are attached and this carbon is having plus charge. So 6 electrons only. 6 electrons only. So who is in need of electrons? Carbon or fluorine? Tell me the answer in the chat section. Who is in need of electron? Definitely carbon is in need of electron. Electron lover. What lover, kids? Electron lover. Now fluorine is saying, hey carbon, I'm having lone pair. Wow. He is also saying I'm having lone pair. He is also saying I'm having lone pair. So all the 3 fluorines will donate electron to carbon. Hey, just accept my lovely electron. Accept my lovely electron. Accept my lovely electron. So donor is 2p. Gainer is also 2p. The bonding of equivalent 2p 2p is approximately same energy. Now see here, this carbon is electron deficient, chlorine, chlorine, chlorine. Now remember that chlorine belongs to which period? Fluorine belongs to second period. If you see fluorine, chlorine, first, second, third period, this belongs to third period. Now in the 3p there is lone pair. 3p there is lone pair. So carbon is saying, hey, just give me that electron. Chlorine is saying, okay, okay, but my 3D is also vacant. His 3D is vacant. Chlorine's 3D is vacant. Now you will say, sir, how to find out its chlorine's 3D is vacant? Who will tell us? Let me tell you. Chlorine's 3D, how it is vacant. Chlorine's atomic number is 17. 1s2, 2s2, 2p6, 3s2, 3p5. Just count. 2 to 4, 6, 10 to 12, 5, 17. So 3D is vacant or not? 3D is vacant or not? 3D is vacant, no electron. Can you see? I have written according to above Pauli and Hunt's rule, this electronic configuration. Have you seen? So its 3D is vacant, vacant. 3D is vacant. Now, chlorine is saying, I will give this electron to your 2p and I will give my electron to my 3D also. So this electron is not coming completely to the orbital of this carbon. It's getting divided. It's coming this side also. It's going that side also. And that's why I have told you who is a better donor, the 2p, because there is no 2D, no 2D. So fully it will donate its electron to the carbon, full dedication, but its electron is getting divided. So who is getting more benefited? Which carbon is getting more benefited? The first one or the second one? The A1 or the B1? This is getting more benefit. So that's why we would like to say it is having 2p pi, 2p pi back bonding, and there it is 2p pi, 3p pi back bonding. Who is better? This is excellent. BB. BB means back bonding. Excellent back bonding will provide more stability. But kids, at the same time, the kids, those who are not able to remember the back bonding, and they will apply minus I. See kids, how they are getting failed. If you are applying minus I, you will say this fluorine will having more minus I and it will snatch more electron, it will withdraw more electron. So it is least stable, that is more stable. So remember that, don't apply minus I first. Always go with Rahis, resonance, then hyperconjugation, then inductive effect, then go for inductive effect. Resonance will be on priority. Everyone, those who are able to understand, this is more stable, this is more stable. Have you got it, kids? If yes, show me green hearts. If not, fire. If you got it, then green hearts. If you are unable to understand, fire. Then I will tell you once again. Shivanshi, welcome, welcome Shivanshi. Everyone, kids, do let me know. You got it or not? Shivansh, welcome, welcome Shivansh. Hey everyone, what are you doing? Then I will give you another question. Before giving you question, let me tell you which back bonding is better, which back bonding is not better. Let me tell you, kids. Remember that 2p pi the donor, the gainer. 2p pi, 2p pi is excellent back bonding. Then 2p pi, 3d pi, the reason for its d orbital contraction. It's very good BB for back bonding. Then 2p pi, 3p pi. If you go, this is good BB. If you see the radial node also, then you can get the answer why the reason is like this. This is the strength of back bonding. Remember that. This is the strength of back bonding. Back bonding is strength. Now, kids, I'm going to deal with another question. This time, don't get failed. Are you ready, kids? Everyone, ready? Question is, once again, which one is more stable? This is your question. Which one is more stable? First is CF3 negative, B is CCl3 negative. Apply your brain. Okay, no hurry. At least apply your brain. Where is Wasim sir? Somebody is saying Wasim sir is there. Thalaiba is there. Hey, Wasim, bro, are you there? B, kids are going with B. Kids, I'm telling you, kids, apply your brain, everyone. Do let me know what's your answer, kids. Okay, let's see. This carbon is having negative charge. This fluorine is also having lone pairs. Now, who is in need of electrons? Tell me who is in need of electrons. Carbon is having 8 electrons. Fluorines are also having 8 electrons. So do you think anyone is in need of electrons? No one is in need of electrons. But carbon is saying, hey, I'm having negative charge. And charge is not a good thing. Please accept my electron. Do you think fluorine is able to accept electron? No 2D, or I can say no low energy vacant orbital. So no BB. No BB. BB means back bonding. There is no BB. He is without BB. He is without BB. But see, here carbon can donate electron to chlorine. Where? Do you think in 2p, 3p? No, not at all. 3d is vacant. Which is vacant? 3d is vacant. So 2p pi, 3d pi back bonding. So your answer is absolutely correct. He is with BB and he is without BB. So that one is more stable, and that is the answer. Very good, kids. I'm so happy. I'm so happy, kids. I'm so happy. You got it. Done and dusted. Really awesome, kids. Really awesome. Now, back bonding is, I hope, clear to each and everyone. So let's move towards third resonance, mesomeric effect. And this will require some time. This will really require some time. Mesomeric effect. Are you ready for that? Kids, do let me know. Are you ready for mesomeric effect? See, mesomeric effect. These are the 5 types of mesomeric effect. But before move towards mesomeric effect, let me tell you kids one thing. I would like to tell you something kids. Before I move towards mesomeric effect, I want to tell you something kids. Now see kids, mesomeric effect if I say it's Tamil people, if I say Tamil people, mesomeric effect is like Tamil people. And resonance if I say Indians. If I say resonance is like Indians. So what do you think? All Tamil people are Indians, but all Indians are not Tamil people. So mesomeric effect is always resonance, always. But resonance is not always mesomeric effect. Whenever I say mesomeric effect, I will always use the word resonance. But whenever I'm using the word resonance, I cannot say always the mesomeric effect. Are you getting my point? After this resonance class will get over, but resonance requires a lot of dedication, patience, consistency. Are you having that? Then only you can do anything. Otherwise, you are going to lose the match kids. If you're having that guts, if you're having that power, if you're having that willpower, you know that where there is a will, there is a way. It is an old saying, but still true. If you think you are able, you can cross any energy barrier. So remember that. Say to yourself, you can do this. All the obstacles in your path will disappear and the means to its achievement will appear in front of you. Now see kids. How many types of mesomeric effects are there? Before I move towards this, let me tell you one more thing. I would like to tell you one more thing kids. If you're not able to understand, then just keep one thing in your brain. If you are having this situation, X, any non-metal, double bond Y, any non-metal, and Z, any non-metal. These are 3 non-metals. X and Y are attached through pi bond. And if this Z atom, if I say it is having either double bond, or it is having negative charge, or it is having lone pair, or it is having positive charge, or it is having free radical, and any of these conditions, double bond, negative charge, free radical, positive charge, any of these 5 conditions, then it will always show a resonance, always. So X, Y, Z are being non-metals. They are being non-metals. Now see to it. Types of mesomeric effect. Pi bond, this is the best. Remember this. Why this is the best kids? Because all the atoms, they are having same energy. That's why this is the best. Now pi bond negative charge, pi bond lone, not tone pair, it's lone pair, lone pair. Pi bond positive charge, pi bond free radical. These are Vana, Randa, Monu, Nale, Anche. 5 types of mesomeric effect. And whenever I talk about mesomeric effect, whenever I use the word mesomeric effect, I can always use the word what? I can always use the word what? Resonance. So Mr. MR For mesomeric effect, I will always use, I have the power to use resonance, right? Now kids, one by one I will explain all of these. Are you ready for that? Or are you feeling sleepy? First of all, do let me know. You are full on energy. If yes, you are having full on energy, then I want to see the chats running speedily with fire and green hearts. Just for complete 2 minutes, I want to see the chat should be running with whatever the speed, possible speed, for 2 minutes with green hearts and fire emojis. Let me check it out, how much energy you are having. Baba is doing really hard work for you, and how many of you really can do a lot of hard work for yourself. Let me check it out. For 2 minutes, let me see the speed. With what speed chat is moving, kids. Increase the speed, kids. I am just watching the speed. Increase the speed, then only the Josh will increase. No. It's now, yes. From no to added W, now it's very good, kids. That's really Romba Sulvam. Vira level. Wow, great, kids, great. You made my day. You made your day. Fantastic, it's fantastic, really fantastic. Now let's see. One by one, I will move with all these types. See, the first one, the best one. The worst one, the best one. The best one. Which one was the best? Do let me know. The best mesomeric effect. Which one? Why this is the best? Because I'm saying the energy level is really awesome. What do you mean by the energy level? Suppose if I draw, this is one road. This is one road. This is what? This is one road, kids. This is one road. And let me say this is another road. This is another road. Second road, right? This is second road. Both are going from Delhi to Lucknow. But this road is having speed breakers. This road is having speed breakers. And this road is without speed breaker. This is A road, that is B road. And Alia wants to go with her car. Alia is having one car. What do you think? Alia will go with which road? Alia is going to opt which road? Alia would prefer which road to go? The first one, A1 or B1? Which road the car will move speedily, kids? Do let me know. Everyone, speedily, do let me know. On which road the car will move speedily, fast? Kids, speedily, do let me know. What are you doing, kids? You are taking too much time. Definitely, this is the best road. Why this is the best? Car will move fast. Why the car will move fast? Car is like electron. Car is like electrons. Will move fast. Will move fast because there is no speed breaker, no obstacle. The energy level of the road is same. All the orbitals are with same energy. Orbitals are having approximately same energy. Orbitals are with same energy or approximately same. Got it? They are having approximately same energy. So this is the best. Which one? X double bond Y single bond Z, and that is attached with pi bond. This is the best. And you will understand what's the meaning of this and why I'm focusing too much over here. Why I'm focusing too much at this place. You will realize this point. Now see, kids. If I say that I'm having CH2 double bond CH, CH double bond CH2. One, this structure is given by the examiner, and another one structure is given like CH2 double bond CH, CH double bond O. Now examiner is asking, draw the flow of electrons in A and in B. Draw the flow of electrons. So remember that in A case, all the electrons are with same energy, the pi electrons. So if it is moving here, this will move on that side. Or if he has drawn that this is coming over here, then this will come that. From left to right or right to left doesn't make any difference. Both are being correct, the flow of electrons. You should know the flow of electrons, otherwise you won't be able to give the correct answer, kids. Are you getting my point? If you can't understand the flow of electrons, you can't deal with the organic chemistry. Everyone, write down yes or no speedily in the chat section. What are you doing? What's going on this chit and chat? Don't do that. Kids, focus on studies. Now, here this is more electronegative atom. This is more electronegative, so only this direction is correct for the flow of electron. Everyone, the flow of electron is clear to all of you. If you are agreed with the flow of electron, if you can't understand the flow of electron, you can't do anything. First point is try to understand flow of electrons. Flow of electrons. Now kids, second thing is that one is extended conjugation. Conjugation is mesomerism or resonance. I can use the word conjugation, delocalization, mesomeric effect, resonance, all they mean same. extended conjugation. Another one is cross conjugation. Another one is cross conjugation. Cross conjugation, extended conjugation. Let's see what is the difference. If I draw one compound like this, CH2 double bond CH, CH double bond CH, CH double bond CH2, and if I draw another compound like this, CH2 double bond C, H, C double bond CH2, CH double bond CH2. Now what's the difference? Let's see. In this compound, this is pi bond, this is single bond, then this is pi bond, this is single bond, then this is pi bond. So this electron is going up to there. What I'm saying, the electron flow can be from here to here, delocalization of pi electron, above and below the plane. The electrons, because p orbital is like, the p orbital is like this. So electrons are going up, they are coming down, they are going up, they are coming down, but at the same time they are going up and down. They will go like this also, they will move like this also, they are moving like this also. Are you getting my point? Here also going up, going down, going up, going down. So the electron flow is over the entire molecule, over the entire molecule, going up, going down, and going like this also, going like this also, going like this also, going like this also. So they will go like this also, this also, this also, this also, like over the entire compound. The delocalization is over there. But see, this pi bond is doing resonance or mesomeric effect with this, but this can't go over there because there are two single bonds, sigma bonds, two digma bonds. So this can't go over there. Even this pi bond can do resonance with this one, but can't do with this one. So there is one node. Can you understand? If I say Alia, Balia and Kalia, Alia and Balia are able to, in talking terms. Kalia and Balia are also in talking terms, but Alia and Kalia, they are not in talking terms, but here all they are in talking terms. So there is no node, no obstacle, so no node. So this will provide more stability, will provide more stability, and the cross conjugation will provide less stability. Got it? Will provide less stability. If it is clear, do let me know in the chat section that this point is absolutely clear to each and everyone, kids. Kids, always show the green hearts if concept clarity is there. Now, what I was telling you, kids, see, if I say that I'm having this compound, just see. This compound's name, write down in the chat section. What is the name of this compound? Now, kids, this compound's name is pyridine. If you don't know, let me tell you, it is known as pyridine. And that one is known as pyrrole. Now kids, see where I was focusing. What is important thing? See, this nitrogen, okay, this nitrogen is having pi bond as well as lone pair. Now tell me, who will do resonance? It is having both lone pair at the same time pi bond. Both the two things are there. So which conjugation is the best conjugation? I've told you pi bond conjugation is best. So pi bond will participate in the resonance. This will not, lone pair will not do resonance. So for this, there is one word. It will remain, this lone pair will remain localized. Got it? Lone pair will remain what? Will remain localized. Will not do resonance. So these three pi bonds, they are doing resonance. This pi bond, this pi bond, and this pi bond, they are doing resonance. But here, this nitrogen is not having pi bond, only lone pair. So lone pair will do resonance. Lone pair will take part in resonance. So this is delocalized, this is delocalized, this is localized, this is localized. Got it? So how it will affect the basic strength? Which lone pair? This is like rabbit. This is like rabbit. Lone pair is like rabbit. Once the eagle is going to attack, this will move and this can't move. So this is more basic. From here, you can get an idea about the basic strength also, that pyridine is more basic. Why pyridine is more basic? Because its lone pair is easy kill. So this here it is basic strength. You are getting the basic strength order also. Now you must have started thinking about aromaticity, but right now I'm not going to deal with aromaticity. First, try to understand. Each and every concept should be very clear to all of you kids. This much is clear, kids? Is this much clear to all of you? Why pi bond conjugation is the best conjugation? Everyone got it, kids? You're not showing green hearts. I think you got tired. If you got tired, I'm going to end this class. If you're not doing active study, then what's the need of taking class? Do active study, kids. Otherwise, I'm not going to teach. I'm going to stop. If you're not having stamina, if you're not having Josh, what's the need, kids? Not required, not at all. If you need break, I can give break. If you want break, then I can give break. That's not a problem. That's not a problem at all. But you should have, you have to do active study, kids. Okay. Okay, kids, let's take after 30 minutes, I will give you one break. After 30 minutes, okay? After 30 minutes, I will give one break. After 30 minutes, right, kids? After 30 minutes, I will give you one break, okay? Even I have not done my dinner. Even I have not. Yeah, very good. Now see, kids. The second one, second mesomeric effect is before moving towards second mesomeric effect, how I can ignore benzene? You know benzene, kids? Do you know benzene? What is this? Do let me know what is this. What is this? Do let me know what is this. Write down in the chats. What is this? Everyone write down in the chat. What is this? It's not benzene. It's not benzene, kids. Why it's not benzene? Because these are resonating structures of benzene. These two are resonating structures of benzene. We will say canonical structures or resonating structures. We will say resonating or canonical structures. Now, this is a resonance hybrid. Now, what is the meaning of these things? Let's deal in detail. Otherwise, you won't be able to do even a single question. Let's see all these things in detail, kids, right? Let me draw on another page. Now, see, kids, these are carbons, 6 carbons. Can you see? All they are double bonded. So that means there is one unhybridized orbital on each carbon. Just try to understand. Everyone just try to understand. Right? Now, if I say, if they are, the electrons are moving like this, see, the electrons are going up, they are going down, making 8. These are electrons are also going up and going down. But these electrons are saying that we will try to form one bond like this also. We want to move like this also. They are saying that we want to move like this also. I will come in your lobe, you will come in my lobe. They are moving like this also. Are you getting my point, kids? Everyone, are you getting my point? The electrons are like a wave, champa. They want to occupy more space. They are feeling good. Even you want. You have seen in COVID pandemic, we were localized. Government said just remain inside your house. You are not able to move here and there. Now see, kids. Now these electrons are saying, I'm going up, I'm going down, I'm going up, I'm going down. But they said, we want to occupy more space, so let's do one thing. I will come to your house and you come to my house. So from upside and downside, they decided to move like this. They are moving like this. Just move here, just move here. No. What's happening over here? Just see, kids. They are moving up. This electron is going down. Electron going up. Electron going down. Now they decided, let's do one thing. I will come to your house. You just come to my house. They are feeling really amazing. Wow. Wow. Now see, kids, what's coming to your brain? Just to let me know, everyone. Just to let me know what other thing can happen. What other thing can happen? Just see. Everyone just see what next thing can happen. Next thing is that these electrons are moving like this. Just move here, just move here, just move here. Just move here, just move here, move here. And these are moving like this. Just move here, just move here, just move here. Just move here, move here, move here, move here, move here, move here, move here. They are moving like this. Going up, going down, going up, going down, just going up, just going down, just going up, just going down. That side, that time they decided to make a friendship. Now see kids, they are saying, let's this time I will have friendship with this one. I will go to his house. I'm feeling good. Now I will not go to his house. I will move to his house. They changed. Oh, you are changing like this. Now I will go to his house. He decided to go his house. Oh, you are going like this. So I will go to his house. Which one is correct? Tell me kids. The first one or the second form, or not a single one. Both are telling something else. Both are giving an idea. Both are giving an idea. So the scientists, they decided that, oh my God, the electrons are not finding any problem. The electrons, they are moving. They are moving, just movia, movia, movia. They are moving like this. They are not having any boundaries. They are free to move over the entire ring. So they are moving like this, just movia, 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 immovia, immovia. They are moving like this, making it. They are moving like this, making it. They are moving like this, above the plane, below the plane. This is the plane, reference plane. They are moving above the plane, they are moving below the plane, but they want to occupy more space. They said, oh, I will move in different way. I will move in different way. I will move like this. Above the plane, I will move like this. Above the plane. Now, they said, I will move like this below the plane. So, actually, neither this structure is explaining correctly, not this structure. Both the two structures are contributing. They are contributors. That's why they are known as canonical structures or canonical, either resonating structures, or we will say canonical structures. Now see kids, if they would have been the correct structures, their expected means theoretical energy was 86 kilocalorie per mole. But because of this delocalization of pi electrons over the entire ring, the experimental energy was found to be 50 kilocalorie per mole. How much less kids? This is known as resonance energy. Final minus initial means experimental minus expected energy. That is expected, no, experimental, and this is experimental, right? Minus 86, so minus 36 kilocalorie per mole. Benzene is said to be stabilized. Now kids, take one break. We will meet at 23:35. 23:35, okay? We'll meet at 23:35 after 30 minutes. Agreed kids? Everyone? Agreed kids? Kids? Yeah, hybrid, resonance hybrid or actual structure is more stable This is more stable, right, kids? Right, kids? Let's meet after 30 minutes, kids. Is it clear? Because some people's battery is discharged. So let them charge their battery, either the phone battery, or you have not eaten something, then eat. Even I want to eat. I have not done my dinner at that time. So kids, let's meet after 30 minutes, right? Okay, kids, will you come with the same ATPs? Will you come with the same ATPs? Kids, do let me know. Will you come with the same ATPs? Very good, kids. Welcome, kids. Welcome back. How is everyone, kids? Do let me know. Can you hear me? Can you see me? Kids, am I perfectly audible and visible to all of you, kids? I want to see some fire in the chat section. If you can hear me, can see me. Fast, kids, fast. Baba is always on time or in time, never late. Baba is never late, kids. Everyone, fast, fast. Let's move on. First, show me some fire in the chat section along with some green hearts. Wow, that's really awesome. That's really fantastic. So let's it go. This was the benzene. It is stabilized by 36 kilocalorie per mole, right? Now, let me tell you the second one. Second one is X double bond Y single bond Z, and Z is having negative charge. Now see the flow of electron. This is having extra electron. Having extra electron, that means having extra electrons. So Z effective will be less. Z effective, if I say, then I would like to say the attraction of the nucleus. In the nucleus, there are protons. So attraction by the proton on the outermost electron is less. Z effective is less. So this negative charge will move. So this will always be the flow of electron. Remember that. If you remember this is the flow of electron. Then whenever you are going to deal with benzene and somebody is giving you compound like this, O negative, now you know the flow of electron. Definitely oxygen will donate one electron and this electron will come over here and this electron will go over there. Now you will get 5 resonating structures, but these resonating structures will not be equivalent because right now the charge is on oxygen. After some time the charge will be on this benzene's carbon. So 5 non-equivalent resonating structures. Now its resonance hybrid will look like this, kid. See, partial negative, partial negative, partial negative, and negative charge is doing resonance and it's moving like this, kids. So where the extra electron density has come, it has come on ortho and para. So we will say this phenoxide is OP direct. This phenoxide is OP director, ortho and para director. This is OP director. Whenever you are going to deal its electrophilic substitution reaction, then the electrophile will come and attack on ortho and para. Now see, kids, everyone just see what I'm going to tell you, that this is donating electron. So it is showing plus I as well as it is donating electron through plus M. And place of plus M, I can write down plus R. So it is electron donating group. Is it clear? Now, my dear students, at the same time, I would like to tell you, if you are having a compound like this, now, if you see this carbon is having pi bond as well as negative charge, who will do resonance? So remember that pi bond and pi bond resonance is the best. So this negative charge will remain localized, will not do resonance. This will remain localized. Remember that. Will not take part in resonance. Will not take part. Who? Negative charge. Negative charge will not take part in resonance. So one word, if I use one word for it, I will say it will remain localized. So this compound is highly unstable. Highly unstable. Are you getting my point? This compound is highly unstable. And if you compare this compound, my dear student, if I say that if it would have given like this, then definitely negative charge is over here, so it will do resonance. This negative charge is taking part in resonance. So this is delocalized, but this is localized. That negative charge is delocalized. Everyone got it, kids? Is it clear? Now let me tell you the third one. Before moving towards third one, let me deal with this compound so that you can get the feel of one thing, that what is equivalent resonance. Non-equivalent, so already I've told you. Now see, right now charge is over here. Now the flow of electron, you know very well, the flow of electron should be like this. Now it will come over here, it will go over there, so it will look like this. Its resonating structure will look like this. Now see, kids, do you find any difference in between X and Y? Are you getting any difference in between X and Y? Both are looking exactly same. So we will say they are equivalent resonating structures. We will say, kids, equivalent resonating structures. So remember that generally equivalent resonating structures provide more stability than non-equivalent because they are giving more stability. So let me write down generally. Remember this point, kids. Generally what I'm saying, generally equivalent resonating structures provide what? Provide more stability than what? More stability than non-equivalent resonating structures. Remember this, generally, but generally, right? Now let me tell you the pi bond and lone pair conjugation. See, kids, pi bond and lone pair conjugation. See, everyone, this is really very, very important. Pi bond and lone pair conjugation. Try to understand the flow of electrons. Once you know the flow of electrons, you can achieve anything, kids. You can do anything. Now, if I say I'm provided with compound like CH2, double bond CH, and here it's written NH2. Now, my dear students, my dear friends, do let me know, nitrogen will donate electron to the carbon or will withdraw? That is the $1 million question. Thanusri, genius, wow, very good. Now, tell me, nitrogen is going to donate this electron. So remember that. Let me tell you the story. Once my father's sister, we call auntie, she was going back. She came during holidays, you know, summer vacation. And once she was going, my father has given her one mobile, 1 lakh rupee mobile. And at the time she was going, she kept 500 rupees note in my pocket. Now tell me, Auntie ji has taken money from our home or she has given money? Do let me know. Champa auntie has given money or taken money? So answer is Champa auntie is taking electron. Through minus I, it's acting as electron withdrawing group. But due to mesomeric effect, at the same time, it's donating. So due to plus M, it is acting as electron donating group. Remember that plus M effect is greater than minus I. So overall donation is more. The same thing if I write down over here, If I write down over here, and this is known as aniline, kids, this is known as aniline. So what will you say? Nitrogen is withdrawing or donating? So definitely through minus I, it is electron withdrawing group. Through plus M, that is known as plus R, it is electron donating group. Overall plus M is more than minus I. So benzene has become more electron rich because it has given more, taken less. Nitrogen has taken less and given more. So overall benzene has become what? Benzene has become more electron rich, has become more electron rich, and mainly at, if I draw its resonance hybrid, then you will see the true structure will look like this. You should know how to draw the true structure, then only you will get clear-cut knowledge about each and everything. So this is true structure. So benzene has become more electron rich mainly at ortho and para. So it is known as OP director. OP director. Now my dear students, the most important thing I'm going to tell you so that you can solve each and every question. You should be in a position to solve each and every question. Are you ready? The case of halogens, that is very, very important. Are you ready, kids? The case of halogens. Now see, kids, in case of halogens, if I talk about halogens case, halobenzene, halobenzene. So if I write down over here halogen, X is halogen. So remember that in case of halogens, minus I dominates over plus M. In case of halogens, if halogen is chlorine, bromine, or iodine, remember that. But if halogen is fluorine, in case of fluorine, minus I is approximately equal to plus M. Neither donating nor withdrawing electron. In this case has been asked during civil services exam. What was the case? Let me tell you, kids. The case was like this. They have given phenol. They have compared the acidic strength of phenol and fluorophenol. Now tell me, kids, which is going to be more acidic? What you should have given. If you would have been on that position, what would have been your answer? Who is more acidic? They asked the acidic strength. Suppose if I say this is X and that is Y, according to you, which one is more acidic? So definitely whatever the answer you are going to give, I don't know, but they are equally acidic. They are exactly equally acidic, kids, because hydrogens and fluorines. Fluorine, whatever is donating through plus M, the same time it is withdrawing the same amount of electron. So Ka value was found to be 1.9 into 10 is for 10. Same for them, same acidic strength was same. Now kids, why this happens in halogens case? You know, nitrogen, phosphorus, arsenic, antimony, bismuth, the rest of the elements are not combined with carbon. Only these are the halogens which are combined with carbon. Let me tell you, kids, let me try to explain, just try to understand. If I write carbon, and if I write down here iodine, you know iodine belongs to which period? Fluorine, chlorine, bromine, iodine. 1, 2, 3, 4, 5. Fifth. So fifth orbital will be double shaped, but too much bigger. Its electrons are like this. Carbon is small, second period element, so its p orbital should be like this. Now suppose if I say iodine is very, very less electronegative, through minus I, it has withdrawn electron, just say 0.2 electron it has withdrawn. I am comparing just for the sake of simplicity. I am comparing, it has taken 0.2 electron. At the same time, it is donating total 1 electron. It is donating total 1 electron from its orbital, but the electrons are in the air. Because of the size overlap, poor overlapping, the electrons are not reaching to the carbon. Are you able to understand what I'm trying to tell you, kids? Because of the poor overlapping, because of too much difference in size. Suppose you want to hug an elephant. If you go and say, hey elephant, I want to hug you, what elephant will say? Oh, you hug my one leg. You won't be able to hug the whole elephant. Will you be able to hug the whole elephant? Elephant is too big. So poor overlapping will be there. Are you getting my point? Because of too much, what too much? Too much difference in size. Very, very poor overlapping. Very, very poor overlapping. So nothing. The electron is in the air. Electron in air. No benefit. No benefit. That's why minus I dominates over plus M. But if this is the case of fluorine, see the case of fluorine. If I say that carbon, double bond carbon, and there is fluorine, you know very well that fluorine is the most electronegative element. Most electronegative element, so minus I is powerful. But this is 2p and this is also 2p. So whatever it is gaining, same it is giving back to this carbon. So minus I and plus M, they are approximately equal. You got it? Everyone, you got it. Now the case of halobenzene is very, very important, and it is going to decide number of things. But I will not discuss that case over here. Or you want to discuss that case? That we will discuss later on. Now see kids. Next is X double bond Y single bond Z and the positive charge. This is double bond we have done, lone pair negative charge, fourth one. This is the fourth point. Now what should be the flow of electron? Just try to understand. Plus charge means no electron over there. No electron. Whenever there is no electron, then definitely what is going to happen? The place where electron is present will come over here. This will develop negative and this will develop partial positive. So what is going to happen after some time? This will have positive and Y will form a bond with Z. These are two resonating structures. The flow of electron will be from pi to positive charge. Pi to positive charge. I hope you got it. You are able to understand. Everyone is able to understand how it is moving. Fourth one I have told you, now the fifth one. But before moving towards fifth one, let me tell you one very, very important thing. What's that? Remember that whenever you see a compound like this, no mesomeric effect will take place. Never. Let me tell you, if it is like this, if it would have been like this, resonance will take place. No problem. If it would have been like this, then also resonance will take place. No problem. Resonance will take place in both the two cases. But in this case, and if it would have been like this, then also back bonding would have taken place. Back bonding would have taken place. But remember that this one, there will be no mesomeric effect. That will not take place. Why, kids? Now see, first of all, see here, these are double bonds. The electron flow, C double bond O I have written. Okay, no problem, but it should be given like C double bond, C like this. So electron will go like this, will go like this. Here the electron will come like this, it will go like this. Here the back bonding will take place. But in this case, oxygen is having lone pair, but it is having simultaneously the pi bond. Now the pi bond will not go to that carbon because This oxygen is more electronegative. It will not allow electron to go in that side. So no mesomeric effect. Never. It's, can you hear me? Everyone? Just to let me know, kids. Are you there? Are you there, kids? Everyone, just to let me know. Hey, kids. What happened? Let me check it out. That I am audible and visible to all of you, kids. Just a second, kids. Just a second. Can you hear me? Can you see me? There was power cut. So everything is gone. There was huge power cut, kids. But I will complete the lecture. There was huge power cut. Kids, are you back? I've tried my level best. There was huge power cut, kids. Now it's back. And thanks, you are there. I will appreciate your efforts. I will appreciate that you never go with the give up. That's really awesome, kids. That means a lot. Let me see, kids, from where I'm going to start. But I think the file is there or it's gone. I don't know. I don't know, kids, about the file. Let's see. Let's see, kids. Let's wait for 30 seconds. It will take at least 30 seconds to 1 minute to get started. See, no signal. Now, let me check it out. Whether the file is there or it's gone. So, let me start from here only. And what to say? Kids, we were dealing with the resonance. So I was telling you, kids, I was telling you, yeah, the case where resonance will not take place. The case where resonance will not take place. Now, kids, how to find out how to compare the stability of resonating structures. Stability of resonating structures. Whenever you are going to compare Stability of resonating structures. Remember, you have to see the priority order. Focus on the priority order. Okay, everyone, you need to focus on priority order. It's hanging, kids. See. Even board is in sleepy mode. Even the board is in sleepy mode. Kids, just wait. I can't move so speedily, kids. I have to tell you each and everything in a decent manner. Priority is maximum, kids. Priority. Now see, first thing is that neutral form is more stable than the charged form, which I was telling you from the starting. Neutral form is more stable than the charged form. Remember that you have to move in this way only, kids. What I'm telling you, neutral form is more stable than the charged form. That means if I write down something like CH2 double bond CH2, this form is more stable than if I write down CH2 positive and CH2 negative, because it is having less bond, it is having more bonds. So this form is being more stable. Got it, kids? Now the second point, what you are supposed to see, the second point. Let's deal with the second point, kids. Just a second, kids. Second point. That octet rule. In the second point, maximum people are making mistake. Remember that what they are doing, I'm not going to tell you, because then you will do the same. What you are supposed to do, see the octet. See the octet. Suppose if I say CH3, C double bond O and triple bond O positive, and if I compare CH3, C double bond O and positive, people will say this is more stable, because they will say that positive charge is more stable on less electronegative atom. But before that, just check it out, kids. This oxygen is having 1, 2, 3, 4, 5, 6, 7, 8 electrons. Even carbon is having 6, 7, 8 electrons. Everyone's octet is complete. But see here, this carbon is having 1, 2, 3, 4, 5, 6. Only 6 electrons. Incomplete octet, and here complete octet. What will you say, kids? Remember this point. Complete octet one is more stable than the incomplete octet one. Incomplete octet one. Got it, kids? So this is the stability order. Remember this. Octet rule is very, very important. You can't ignore this. You can't ignore it. Right? Now, if this is also not the difference, then you can go for the third point. Just see that negative charge is more stable on more electronegative atom, on more electronegative atom. Now see, kids, let me compare all the points till now, whatever I have told you. Suppose I am provided with formic acid. This is maximum stable. Then HC positive, O negative, OH. Then HC negative, O positive, OH. The three form X, Y, and Z I have written. X is neutral form. Y, here 6 electrons. Z, here 6 electrons. So negative charge is more stable on more electronegative atom. X, then Y, then Z form. This is the stability order. I hope that this is clear to each and every one. Now the fourth point, that opposite charges should lie nearest. Now fourth point, opposite charges must be present nearest to each other, nearest. What do you mean by that? Let's see, have a look. If I say this is phenol, you have always seen phenol like this, but when you grow up, you have seen phenol like this also. We will say that A is equal to E. Then these positive and negative charge are nearest. So we will say B and equal to D. So last, because they are far away, C. Got it? Everyone, kids, we are moving fast, but we cannot ignore the concept. We cannot leave the concept. Everyone, if you are able to understand, just to let me know with the green hearts that everyone, you got it. Everyone, just to let me know. Everyone, just to let me know, kids, you are able to understand. If yes, I want to see green hearts from each and everyone's side, kids. Everyone, just to let me know. Do let me know, kids. Fast, fast, kids, fast. Very good, very good. That's fantastic, Varsa. Shubhatma, very good, fantastic. Now, let's move with the applications. Applications. That's really awesome thing. We are going to deal with applications. Applications. Application number 1, aromaticity. Aromaticity, kids. Before we move towards aromaticity, let me take out something to speed up. Let me take out something to speed up. Kids, you are powerful person. You will get rank, kids. I know that. If you can do this much hard work, definitely Almighty God will bless you with the best rank, kids. No one can stop you with that rank, kids. See, kids, you will get notes. That files have gone, no problem, but notes, you will get all the notes. See, the fantastic notes. See, everything is over there. I will provide you. I have done a lot of hard work for you, kids. See, applications of resonance, 10 most important. Aromaticity and anti-aromaticity. Say yes, kids. That Baba is great. Backup is always there, kids. Once the file has gone, no problem, but backup is always ready, kids. See. Backup is always ready, kids. Now see, aromaticity and anti-aromaticity. See. For aromaticity, what is required? For aromaticity, LCP HSP. won't be able to understand. Let me tell you. For aromaticity, what is required? Remember that LCP, LCP. Generally, people, they know about H and P. H and P, you know only this thing. H stands for Huckel's rule. And P stands for planarity rule. Planarity rule. Huckel's rule says the ring must have conjugated pi electron system, and that pi electron system must follow what? 4n plus 2 pi rule. 4n plus 2 pi electron system. That means if you keep the value of n to be 0, 2 pi electrons, 1, 4 1 ja 4 plus 2, 6, 2, 2 4 ja 8, 2, just keep on adding 4, 10 pi electrons and like that. The ring must have these many conjugated, and planarity rule says at least one planar ring should be there. The ring must be planar. Ring must be planar. Now let me give you what is the meaning of LCP. I will tell you later on. This is the most important thing. Tough questions it will require. Whenever we are going to deal with tough questions, it is required over there, right? But first, let's see. These are the basics. Everyone is supposed to know these are basics. Now, secrets. How will you understand this? Just secrets. How to count? Counting of pi electrons. Counting of pi electrons. How will you count pi electrons? That is the most important thing. Remember that one pi bond stands for 2 pi electrons. 2 pi electrons. One lone pair stands for 2 pi electrons. One negative charge stands for 2 pi electrons. One positive charge or boron means 0 pi electrons. 0 pi electrons, 0 pi electron. This much is clear, kids? Say this much is clear. I think now studious students are there. The number is fixed, 47 right now. I think only studious students are left. No one else is left. Okay, now see. How to see the planarity? How to see the planarity, kids, right? Let's see the planarity also. Let's talk about the planarity also. Remember that if I say C double bond C, double bonded carbon means sp2 hybridized. sp2 hybridized. Now if I talk about C double bond C negative charge, now very important thing I am going to tell you about negative charge. That is very important, kids. If adjacent to this negative charge, the adjacent carbon is sp2, then this will also be sp2, responsible for planar. But if the adjacent is one is sp3, this one is also sp3, not planar. It's not planar. If it is not planar, can't be aromatic. They are responsible for planar. They are planar. Now, if I talk about carbocation on the other hand, whether the carbocation is like this or the carbocation is like this, the carbocation in both the two situations, it will always be sp2 hybridized only. Adjacent is sp2, then also sp2. Adjacent is sp3, then also sp2. Or if it is boron, then also it is sp2. This is always responsible for planarity. If the compound is given like this C double bond O, then also it is sp2 responsible for planarity. All they are being planar except this. This is not planar. If this much you are able to understand, do let me know so that we can rush towards the questions. Everyone, this much everyone is able to understand, do let me know in the chat section. Then we are going to move towards the questions. We are going to play. Oh, good morning to everyone, kids. Good morning to everyone. One day is gone. Good morning kids. Now, if I talk about kids, if I say you see this compound, is this planar? Do you think is this compound planar? Yes. All the carbons are attached with the double bonded carbons, so this is planar. It is following planarity rule. It is following Huckel's rule. Yes. This ring is having 6 pi electrons. That comes under Huckel's rule. So this is declared to be aromatic. Am I right, kids? It's being aromatic. Now if I say that I'm having this compound, now the way you have to see this compound, don't see individual ring. I've told you LCP, always go with LCP, longest conjugated periphery, longest conjugated periphery. Longest conjugated periphery is saying that you should consider this as one ring. This as one ring. This is planar. Yes, it is following planarity rule. How many pi electrons in this way? Just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 pi electrons, so it is following Huckel's rule. So this is declared to be aromatic. Got it, kids? Now, kids, this much is clear. This is clear. Kids, do let me know, everyone. Till now it's clear. Now see. If I say we are provided with the ring like this, and another ring like this, now see, it is having total how many pi electrons? 1, 2, 3, 4, 5, 6, 7, 8. Out of 8 pi electrons, how many are delocalized? Only 6 are delocalized. Only 6 electrons are delocalized. So these 6 electrons are the part of ring. So it is following planarity rule, Huckel's rule. So it is declared to be aromatic. Now see over here, this is localized, not the part of delocalization. Right now I have explained it or not? Tell me. Let me check 47 how it is constant. Something is, let me check it out. This is right or wrong? Yeah, that was wrong. 63, not 47. Okay. Now see kids. Now here all six, there are six. So 6 out of 6, 6 out of 6 are delocalized. So it is also following planarity rule, Huckel's rule. So it is declared to be aromatic. Right? Pyridine is aromatic, pyrrole is also aromatic. Now let me tell you the most important thing, anti-aromatic, and what's the difference. Aromatic is most stable compounds. Aromatic are most stable than non-aromatic. And who is being least stable? Anti-aromatic compounds are least stable. Anti-aromatic compounds are being least stable kids. Now remember that one point, let me make very clear. These are planar. These are being planar. These should follow Huckel's rule, that means 4n plus 2 pi electron system, and they follows 4n pi electron system. So what is common in between these two? Common point is that planar ring. They must contain planar ring, and they also must contain planar ring. So this is a common point in between these two. This is the point. Now, if ring is not planar, then the compound can never be aromatic and can never be anti-aromatic. So to be aromatic or anti-aromatic, the ring must be planar. Now see, let me give you example of this compound. If I say I am having this compound and it is like this, so it is having 4 pi electrons, so it is declared to be anti-aromatic. Anti-aromatic, and this is having 6 pi electrons, and this is declared to be, you know very well, aromatic. Now if I say, if I draw one compound like this, and if I put 2 pi electrons, ring is not planar. 2 pi electrons are there, but ring is non-planar. Got it? Ring is non-planar. Non-planar means non-aromatic. One point is clear, and this I have compared in the stability order like this. This is the stability order. Everyone, is it clear, kids? Now, see, I'm going to give you compounds. You have to tell me whether it is aromatic, non-aromatic, or anti-aromatic. Are you ready for that? Are you ready for that? Tell me, this is aromatic, anti-aromatic, non-aromatic. Anti-aromatic, non-aromatic, or aromatic? Three compounds I have given. Three compounds, X, Y, and Z. Do let me know. Fast, fast. Very good, very good. So this is sp3 hybridized, non-planar, so non-aromatic. This is planar, and 1, 2, 3, 4, 4 pi electron system. So this is anti-aromatic, and this is planar and 6 pi electrons. So this is declared to be aromatic. I hope you got it. I hope everyone got it. Now I'm going to give you one question. Another question. See, if I say that I'm being provided like this, now this compound, tell me about this compound. This is aromatic, anti-aromatic. What will you say about this compound? Let's see who is able to give the answer of this question, kids. Let me check it out. Who is the powerful person who can answer this question, kids? Answer. This is rank deciding question, kids. This is really a rank deciding question. Let's see who can answer it. Rank deciding, kids. Fast, fast. Everyone is writing aromatic. One kid has written anti-aromatic. See, if you see the longest conjugated periphery, what you will see? Longest conjugated periphery. This is planar one ring. Consider LCP, LCP. Longest conjugated periphery. How many pi electrons are coming on his way? 1, 2, 3, nothing, 4, 5, 6, 7, 8 pi electrons. Planarity, it is following 8 pi electrons are coming, so it is anti-aromatic. Remember that. Or you could have done it in this way. See, like a child. You could have done it like a child. Let me tell you what way, like a child. Why I am saying like a child. If you see, this ring is aromatic, one ring is aromatic, another ring is anti-aromatic. Remember that aromatic plus anti-aromatic will become to be anti-aromatic. You can do like this also. Whatever the way you like, you want to go, you can go. Both the way will give you same answer. I hope that everyone this is clear. Everyone just to let me know this is clear or not. Now let me tell you about annuline. Annuline. Very, very important annuline. Monocyclic conjugated ring. Monocyclic conjugated ring. This is the annuline, monocyclic conjugated ring. For example, if I say smallest annuline is this one. Now either count carbon or you can count electrons. This is known as 4-annuline. This is anti-aromatic. Got it? Now this benzene is also known as 6-annuline. One ring with alternate double bond, 6-annuline. 6-annuline is declared to be aromatic. Now give your suggestions for 8-annuline, 10-annuline and 12-annuline. Just to let me know what's idea about these. Tell me. 8, 10 and 12 annuline. What you will say? They are aromatic, anti-aromatic or non-aromatic? Do let me know. So let me tell you, kids, always put in your brain, all these three are non-aromatic. Now you will say, oh sir, why and how? Explain why and how. Remember that, my dear students, 8 annuline, this structure is absolutely wrong. Remember that this structure of 8 annuline is wrong. Wrong structure. I can prove it mathematically, but right now it's not required because NTA will not ask. It's a wrong, totally wrong structure, kids. So remember that 8 annuline is actually tub shaped. This is 8 annuline, remember that. Here the bond angle, if something is sp2 hybridized, the bond angle should come out to be 120 degree, and it's over here. So this is non-planar, so non-aromatic. Clear? Remember that. 8 annuline is also known as COT. COT stands for cyclooctatetraene. Cyclooctatetraene, COT. Now let's see about 10 annuline, kids. What's the problem in 10 annuline? Let's see. 10 annuline is like this. Now kids, always remember that if I make like this, it's looking like C, and this is looking like Z at double bond. What I'm trying to tell you, this bond is going right hand side, so hydrogen is on left hand side, right hand side, so hydrogen is on left hand side. It's looking like C, so it is cis. Now this is going this side, hydrogen is over here. This is going that side, hydrogen opposite side, so it is trans. Whenever you see something like C, it is cis, Z, then it is trans. So try to understand, hydrogens are going out, cis, hydrogens are going out, cis, hydrogens are going out, cis. But see over here, one hydrogen is going out, one hydrogen is coming inside. Here also, one hydrogen is going out, one hydrogen is coming inside. Now, there is repulsion of electron as well as atom at this place, and these two are trans. So, what's the problem? Now, my dear students, at same place, two hydrogens cannot occupy the space. Two electrons can occupy that. They can collide with each other. They can be present at the same point at the same moment of time. But two atoms cannot occupy the same space. Suppose if I am standing over here, another person, Ramu Pandu, cannot stand over here at the same time. So they will move, like they will try to shift, like two hydrogens are like this. One hydrogen will try to go up, another hydrogen will try to go down. Just like in Maruti 800 or auto, if four persons, they try to, bulky persons, they try to sit, occupy the space, one will go a little bit front side, another one has to go a little bit back side. Then only they can accommodate. So, you know that sigma and pi bonds, they are perpendicular to each other. If I say this hydrogen is tilting a little bit upside, its pi bond will go like this, and another hydrogen is tilting downward, its pi electron will go like this. Rest of all the pi bonds are coming like perpendicular, but they are going a little bit up and down. So their resonance with other neighbor members will break. What I'm saying, these this p orbitals interaction will break with other p orbitals, so there will be no delocalization of these pi electrons over the entire ring. What I'm saying, you are able to understand. This is known as steric inhibition of resonance, SIR effect. What is the meaning? Steric inhibition of resonance. And why this has happened? Who has created it? Due to trans effect. It is all possible because of due to transangular effect. Examiner will ask, due to transangular effect there is SIR effect, and due to SIR effect ring is non-planar. Ring has become non-planar, and once the ring has become non-planar, that means non-aromatic. Got it, kids? So remember that transangular effect has given SIR effect. SIR means steric inhibition in resonance, and the ring has become non-planar. If you got it, I want to see some fire and green hearts in the chat section, kids. Kids, do let me know. Everyone, you got it? Now, the case of 12 annuline. See, kids. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's looking like anti-aromatic, but if you see, these hydrogens are coming inside. Now what will happen? All the 4 hydrogens, due to transangular effect, what will be there, kids? Do let me know. Due to transangular effect there will be SIR. Due to SIR there will be non-planarity, and due to non-planarity non-aromaticity. Remember that. Now if I draw 14 annuline, it's aromatic. Why it's aromatic? Let me show you. To see too much space is there. The hydrogens are far away. You can see these hydrogens are far away. So ring is planar following Huckel's rule, 14 pi electrons. So it is declared to be aromatic. I hope that aromatic is clear, kids. Yes, green heart means this thing. Yes. Wow, thank you for helping, kids. You got it? This much you got it, kids? Do let me know. This much is clear to each and everyone. If yes, I want to see green hearts. Now, next is this one. See, this is known as tropylium cation. Tropylium. Tropylium. This is aromatic or not? Answer is yes, it is aromatic. Now, this is known as tropolone. Now, if somebody is asking, this is aromatic or not? Yes, answer is yes. This pi bond is having free rotation. This will move. So it will remain like this. So forward direction, delta G is negative, and because this pi bond is having free rotation, so this is charged. So dipole moment, dipole moment is equal to charge into distance. So charge is there. So this compound is declared to be highly polar. What I'm saying? Tropolone is highly polar, having high dipole moment. High dipole moment. It will have high dipole moment. Now, how to understand, sir? How to compare the dipole moment? Just see. If I say I'm having one compound like this and another compound like this, now examiner will ask question, which is more polar or which is having free bond rotation. Suppose this is X pi bond, this is Y pi bond. We are having two compound. Now see, if this pi bond is moving, see what will be the situation. Plus, minus, this ring will become anti-aromatic. See, 1, 2, 3, 4, planar, and 4 pi electrons. So anti-aromatic, do you think any compound is going to become anti-aromatic? So we will say this will not happen. Its delta G is positive. This will not move in the forward direction. It will remain in this form. Now, if you see this compound, if this is going to move, it will look like this. See kids, it will look like this, and it will be pi bond. We will say it is having free rotation. This pi bond is having free rotation, and I would like to say that pi bond is having frozen rotation because it will not move. This is frozen rotation. Got it, kids? If yes, I want to see some green hearts, kids. Lag is there. I don't think lag is there. No, kids. Right now, no lag. Do let me know. Everyone is able to hear me, see me, kids. Let me see how many likes are there, kids. Those who have not given likes, give likes, kids. If you have not given till now the likes, I want to see likes from your side, kids. Everyone. Now, after this, let's move towards third application. Third application, kids. Ready for the third application, kids? That is carbocation stability. Carbocation stability. So carbocation stability depends on following factors. Baba, Rahis. Remember this trick. Baba, Rahis. Can you remember this trick, kids? Everything will become simple if you remember this trick. If you keep this trick in your brain, these are the factors responsible for and this is the order. If you want to get full marks, remember this in this way. D stands for, anyone? D stands for dancing resonance. Remember that, dancing resonance. A, aromaticity. E, equivalent resonate. Back bonding. Resonance. hyperconjugation, inductive effect, percentage of S character. Got it? Now, where this dancing resonance is possible, let me tell you, kids. This dancing resonance now see kids, if whenever you see compound like, even board is feeling sleepy kids, but we are not feeling sleepy, right? Even the board is feeling sleepy. Am I completely audible, clearly audible or not, kids? Do let me know, am I clearly audible? Whenever you see, whenever you see carbon plus charge with this three-membered ring, remember that dancing resonance is there. What is dancing resonance? Not required, but dancing resonance will be there. These are the most stable carbocations because they are stabilized by what? Kids, these are stabilized by, say, dancing resonance. These are stabilized by dancing resonance. After that, everything is clear. Let me write down what is dancing resonance. Then carbon with three phenyls. Before that, let me write down propylium cation. Before that, let me write down propylium cation. And then carbon with three phenyls. Let me write down 5. 5 means phenyl. 5 means phenyl. Then carbon with 2,5-phenyl and 1-methyl. Let me write down Me for that. Then carbon just with 2 phenyls, hydrogen. After this, let me write down carbon with 1 phenyl, rest methyl and hydrogen. Now carbon with 1 phenyl, benzyl. But let me tell you kids, in between these compounds, there is too much controversy. Which two compounds? If your brother or sister is preparing for IIT, then do not fight. For IIT, this is more stable. Let me write down. For IIT, this is the stability order, and for NEET, this is the stability order. Don't say like that, sir, what are you talking about? Yes, I am absolutely correct. This is for IIT and this is for NEET. In both the two examinations, they have asked number of times this question. So remember this. This is very, very important. People fight for it. Number of people, they have lost their job also while fighting for this. So I will not say anything, kids. In both the two examinations, they have asked this question. So remember like this and do not fight ever, kids. Do not fight. Do not fight ever, kids. Now after this, it's allyl. Although this allyl is having equivalent resonating structures, but then also this will come after that. Then it will come after that. Now after this allyl, after that allyl, I would like to say it's isopropyl. After isopropyl, it's ethyl. And if I put isotopic effect, then it is CD3, then CT3, then it is methyl. In methyl also, I've told you if there is tritium, so CT3, CD3, there is no hyperconjugation but isotopic effect, then CH3 plus. This is the complete order I have given you. Whenever you deal with this, you should understand. Now, whatever I am going to tell you, that will require brain. Are you able to use your brain? Kids, do let me know. Are you ready to use your brain? That is the most important thing I am going to teach. Is everyone ready, kids? Now, see. Stability of, we are going to deal with stability of benzyl carbocation. Benzyl carbocation by changing position of groups. By changing what? By changing position of same group. What do you mean by this? By changing position of same group. Let's see, kids. Let's try to understand. Because once you are able to understand this thing, you can do anything. You can solve any question, but it will require your brain. So are you ready? I don't know what's the duration, kids, how much more time it will require. I know only one thing, that I have to tell you this thing, then acidic strength, and then basic strength. Then definitely it will get completed, kids. Don't worry. Don't worry. It will not take too much time. So let's go with the flow, kids, right? Let's go with the flow. Now see, kids. If I say that I am having first group, case number 1, minus M and minus I. In both the respect, it is electron withdrawing group like NO2, not A. If I put this group on benzyl, so let me write down benzyl. Apply your brain. Once let me put not A over here. Once let me put not A over here. Once let me put not A over here. Once without not A. These are the 4 ones. Apply your brain. Let's see how much your brain is brainy. Tell me most stable. Out of these 4, most stable is? I'm waiting for your answer. Just half an hour. Don't go. Tata, DK, don't go, okay? Do it. Just half an hour more, kids. It will get completed. Definitely it will get completed. Half an hour more, kids. Fast. DBCA. Very good. D. No. First D, but see, let's see the situation. This is going to put plus charge at ortho, meta, para, and ortho. This charge will increase charge. So due to minus M, charge increase, let's say some points, 4 points. Okay. Now here its ortho is this one, ortho, para. Now this charge is not affecting this, so minus M, no effect. Remember that from meta, minus M is not effective. Remember this point. Mark my words. Categorically, I am telling you this particular point, that from meta, minus M or plus M, mesomeric effect is not operative. Now, if you see, its ortho is this, para is this, ortho is this. So due to minus M, charge increase that same, because mesomeric effect does not depend on distance. Inductive effect depends on distance, but mesomeric effect is not dependent on distance. Now see, it is applying minus I also. So due to minus I, because it is closest, I will say charge increase this much. Here it's far away, little bit away, minus I, charge increased this much, little bit less than that, and it is far away, so minus I, let's say charge increased this much. So let's calculate, let's summarize. Its total charge increased 7 much. 1, 2, 3, 4, 5, 6, 7. I don't know why 7, 8, but just a comparative study I am doing. Its charge increased too much, and its charge just increased. If I summarize, 1, 2, 3, 4, 5, a little bit more than that, little bit more than the first one, or less than charge increase. So this is the least stable because its charge increased this much. So stability decreased highly, very highly, kids. So who is most stable? You got it. D. After D, this is having least charge. B. After B, that is having C, D, B, C, A. How many of you got this answer? If you got it, then really you have done a great job, kids. Do let me know in the chat section. Oh, DBCA. Number of students got DBCA. Congratulations. You're rocking, kids. Congratulations. Really the best you are getting. Wow. Now, case number B. Case number 1, case number 2. Minus M, no, plus M minus I, like OCH3, like OCH3. Now let me draw once again benzyl. This time I want answer from each and every one of you kids. OCH3, benzyl, OCH3, benzyl, OCH3, benzyl, 4 compounds. Now do let me know, kids. Let's see once again. I want the correct answer from everyone's side. Wow, kids. Thank you. Smash the like button also, kids. Smash the like button also. CADB. Let me check it out. Now this is donating electron through plus M. So it will come over here. Now negative and positive, there will be attraction. So charge decrease too much. Now it is giving its ortho and para, no effect. Plus M's, no effect there. It's not effective from meta, right? Not effective, as I have told you in the previous case also. Now it will put electrons. So due to plus M, charge decrease like that. Same, whatever I have given over there. Now due to minus I is also there. So minus I, it is withdrawing electrons, so charge will increase. Minus I, charge will increase. Minus I, charge will increase. So let's do the calculation. 3 has gone with 3. So overall charge decreased too much. Increased, and here 1 has gone. So here charge increased maximum. So most stable is C, then after C, A, then D, then B. Am I right? CADB. Who has given this answer? CADB. My God, kids. Remura, Hens. You kids are so brilliant. I have no words, kids. Really, you are so awesome, kids. What to say? What should I say, kids? You are really awesome. Now, you have done really the great job, kids. Same thing if I talk about carbanion. So the carbanion, the phenol and the benzoic acid, all three will have same case. So let me directly dive into the carbanion and let me check it out whether you are able to solve it or not. Okay, should I? Let's see. Thank you kids, thank you. Now see, carbanion, but let me change. Carbanion stability. Now see kids, if I talk about carbanion, let's see how many of you can do this. This will help you in everything, kids. Now the same case, let me put NO2 at this point. NO2 over here. NO2 over here. Let's see how many of you can do this. Really, mission will get accomplished if you are able to do it. I will feel like a pro if you are able to do this. I will really feel pro, kids. if you are able to do this. Let me check the camera setting little bit. The color is getting changed, so let me see the camera setting, kids. I think it's okay. Clearly visible, kids. Whatever I'm writing, it's clearly visible, or it's looking like dull, or it's clearly visible. Kids, do let me know. It's clearly visible or looking dull. A, B, C, D. Let me check it out. A, no. C, kids. This will put plus charge over here. This will put plus charge over here. No effect. This will put plus charge over here. So maximum stable will be this minus I and minus M, stabilized by minus M and minus I. So this is most stable. A, then C, then B, and then D. Is there anyone who got this answer, kids? If you want to understand, then I will explain. And if you got it your mistake, then do let me know in the chat section. That's yes, we got it. Now let me A, B, C, D. Number of people, oh, A, C, B, D also some people have written. So they got it. They got it, kids. Now see those who are unable to understand it, let me tell you. So minus M charge is decreased, plus minus decreased. Suppose if I say 5 points, then minus I charge is decreased 3 points, total 8 points. Here minus M is not effective because from meta, mesomeric effect is never effective because it's going from here and there. No, it's not coming over here. Now minus M charge decrease same like A, and minus I only charge decrease a little bit, so this much. So where maximum charge is decrease? Here only. So this is most stable. You got it? Now second one. I hope everyone is able to understand, kids. Now tell me, kids. Let's see how much genius you kids are. BDCA. Let me check it out. B minus I. Very good. D. Very good. C. No. BDA. Minus I is more. BDA. C. This is the correct answer. BDAC. Tell me, kids. B, then D, then A. Minus I is more than that. BDAC. BDCA. No, not CA. BDAC. Let me tell you. What's happening? Let me tell you, kids. Minus M, no, plus M is equal. Just see, plus M is equal. Whatever electron this one is giving, giving electron, giving electron, giving, so yes, giving, giving. So whatever electron due to plus m this one is giving, so it is increasing the charge. Charge increased is same like here, same here, because resonance does not depend on distance. Plus m, charge increased. 1, 2, 3, 4, 5, same. But minus I, because it is nearest, distance dependent. So minus I, charge decrease or increase? Is it electron withdrawing? So decreased. Here minus I, charge decrease. So let me cancel out. This has got cancelled out. So overall this much charge. This has cancelled out. So this overall charge increased like this. And here only minus I, so charge decrease only. So here decreased only. So which one is having least charge? B, then D, BD, then AC. Got it? Everyone got it or not? Got it, got it. That's really awesome. That's really awesome. Congratulations. But C so shows no. It's plus M, na? Plus M to charge increase. Due to plus M electron it is giving negative, and negative charge will increase, na? Plus M and plus M. Both are showing plus M. This only minus I. Plus M is not effective. Zero effect of plus M over here. Got it, kids? Everyone got it? Everyone got it, kids? Now, let's see the effect of all these things on the acidic strength. Only 20 to 30 minutes we will take, kids, then the class will get over. Only 20 to maximum 30 minutes, kids. Everyone, are you ready? Kids, are you ready? Only 15 to 20 minutes only, kids. Okay, now see. Next application is acidic strength. We are going to deal with acidic strength. But see, number of questions, number of things I have given for aromaticity. See Huckel's rule, aromaticity, see notes, need notes, see kids, light, electricity cut was there. So I have given you notes, see kids, the backup, kids, see the backup. These are the notes which I am providing to you, kids, backup. See the backup, Annulene, rank deciding, Annulene, see kids, backup. What will you say about the backup? Electricity was gone, but backup is there, see kids. 20 minutes more, 20 minutes more. Baba's backup plan. See anaconda questions. 4 annulene, these annulenes. See, whatever I have explained, I am giving you the backup. Baba is doing really a great job. Electricity was gone, but I am giving you the backup or not. See, better than whatever I taught, better than whatever I have written or not, great. Tell me, better than that or not? See carbocation stability, they baby rahis. Whatever I taught you, see, nothing is lost. Carbonine, see, carbonine, see. Explanation also, see, double backup. This in detail. This already I taught you. Now kids, the last two topics. Are you ready, kids? The acidic strength. Now see, kids, in acidic strength, I would like to tell you ortho effect. First thing is ortho effect. Just see ortho effect. Are you ready for that? Ortho effect. Are you ready for this ortho effect, kids? Ortho effect says any group when attached, any group means electron donating or withdrawing. When attached at ortho position in benzoic acid will always increase acidic strength. Now, kids, one question arises that if it is electron donating, then different things should happen. If it is electron withdrawing, then different things supposed to happen. How they are, both of them, they are increasing. And let me tell you, even atoms like even bromine and iodine will also do the same thing. Even bromine and iodine will also do the same thing. Now let's see, kids. Why and how? Just see why and how. If I say the normal benzoic acid is like this, and once it has donated proton, this is having negative charge, but this pi bond is doing resonance with this benzene also. So it is doing resonance with this negative charge, as well as this pi bond is doing resonance with this benzene. So it is going to form non-equivalent resonating structures. It is going to form non-equivalent resonating structures. But remember that if any group is attached, bulky group or any group, now this group will put steric hindrance on this. due to steric hindrance of these ortho groups, this pi bond will change its plane, just like there. Due to transangular effect, there was SIR effect. Due to steric hindrance at ortho position, due to steric hindrance at ortho position, these two bulky groups, due to bulky groups, there will be SIR, steric inhibition in resonance. Now this won't be able to do resonance with benzene. It will do full-time resonance with this one only. Now it will form two equivalent resonating structures. So resonating structures will provide more stability. So conjugate base is more stable. So respective acid will become more acidic. Got it? So this, its acid will become more acidic. This much is clear to all of you. First of all, do let me know, kids. Till now, it's clear to each and everyone. Any doubt to anyone, kids? Any doubt to anyone, kids? Kids, do let me know. Any doubt to anyone? Now, the basic strength. But before going towards basic strength, let's do some questions. Let me check it out whether you are able to do questions or not. Let me check it out, kids. Everyone, are you ready? Tell me the answer. Tell me what's the answer, kids. And those who are new, just hit the like button. Smash the like button if you're new, kids. Kids, if you're new, I want to see everyone. Hey. Do let me know. A, D, C, B. One answer is A, D, C. Let me check out. A, then B, then C, then D. This is the answer. If your answer is like this, tell me. If not like this, then tell me. A, B, C, D. Two-side bulky group. one bigger group, then smaller, and no ortho effect. Fluorine will not cause any ortho effect. Here, no ortho effect, no ortho. Got it, kids? If it is clear, done and dusted, then I will move towards another question. Kids, do let me know. Sirajdeen. Yes, how I can forget you. Sirajdeen, wow. After a long time, Sirajdeen. That's really awesome. Now, kids, another question. This is brilliant question, kids. Let's see who can answer it. Brilliant question. Let me check it out. Who is going to give the correct answer, kids? Fast. Gets fast. A, B, D, C. Let me check it out. Maximum ortho effect. So A is right. Then ortho effect B is right. Then very good. D, then C. C will be at the last. Who has given this answer? Really awesome, kids. Really awesome. Fantastic answer. Fantastic. A, B, D, C. Wow. Now there is only plus I. Only plus I is valid over here. Here plus H and plus I. In these two cases, ortho effect. More bulky, more ortho effect. Yes, this one. Fast gets fast. Fast gets fast. Answer is A, D, C, B. Let me check it out. Minus M, minus I. A is right. After A, D, then C. Wow, kids. Then B. Really awesome. You are doing a real great job. Really a great job. Now, what questions should I give you, kids? You are doing it so speedily. Now tell me. Now let me check it out. Who is going to give the answer of this question? That was at meta position, Chatra. That was at meta position. See? So this is donating electron. This is giving plus charge, Chatra. So it is stabilizing it. This is due to lone pair giving more. So it is destabilizing it. And it is also destabilizing through plus H. This is through plus M. So, and this is doing nothing. So A, then D. Out of these two, this is more acidic because it is giving electron due to plus M H. This is giving due to plus M. Plus M is more dominating than plus H. So that's why it's a comparative one. Chatra, you got it? Chatra, it's clear now? A, B, D, C. A, B, D, C. Let me check it out. A, right. B, right. D, right. C is right. Absolutely correct. Absolutely correct. Absolutely. Now tell me. A, C, B, D. A, ortho effect is there. C, B, D. Who is doing this question? Really awesome. You are like a teacher. You are doing like a teacher. Who is this? Remuru. Remuri. Ovalakshmi. Haynes. Everyone claps for yourself, kids. Burma. You are really doing a great job. Commendable job, kids. Really awesome. Now, kids, see. If I give the question based on this, if I say this is phenol, if I make it phenol, now remember that in phenol there is no ortho effect. No ortho effect. And let me tell you, in phenol, each addition of NO2 group at ortho or para decreases pKa roughly by 3. Roughly by 3. So if I say kids, its pKa value is 10, approximately 10, then its pKa value is 10, 3, 3 is 9, approximately 1. Then it's, and this is known as picric acid, you know, the acid without any acidic group. 10 minus 3 and then 3 means total minus 6. So it will come out near about 4. Now, this is very, very important. Never make a mistake over here. This is $1,000,000 question, kids. See, remember that in phenol there is no ortho effect. Why? There is only one atom which is big. In benzoic acid there are 3 bigger atoms. That's why ortho effect is there. No ortho effect. First thing. Don't get confused. No ortho effect at this place. And it is less than this because of chelation. Chelation, you know, stabilized by intramolecular hydrogen bonding. So will not release H. And its pK is very slight difference. Let me tell you, its pK is 3.7. I've forgotten, it is 8.34. 7.14. Yeah, I got it. 7.14. 3.14. How 3.14? 7.14. 7.24. This is the acidic strength order. Remember that. Very, very important thing. Very, very important. Now, only 10 minutes I will take to explain the last topic, basic strength. Right, kids? Basic strength. Agreed? Just last 10 minutes, then the class will get over. Then and dusted, I will say, I taught you each and everything, kids. Agreed? Last 10 minutes. Basic strength. Just remember one thing, one quote. God has given lovely life. Don't drink alcohol. Don't drink alcohol. God has given lovely life. Don't drink alcohol. This is the trick. God has given lovely life. Don't drink alcohol. Now, what is the meaning of this? This G stands for guanidine. What, kids? Guanidine. This G stands for guanidine type. This stands for localized electron. Localized lone pair. This is also localized lone pair. Now, what is the difference? I will let you know. This stands for delocalized pi electrons. This also stands for delocalized pi electron. What is the difference? I will let you know. And this is for amides. Let's move one by one. But first of all, do let me know. The trick is clear to all of you. God has given lovely life. God has given lovely life. Don't drink alcohol. God has given lovely life. Don't drink alcohol. Okay, God has given lovely life. Don't drink alcohol. Now let's deal with guanidine. Acidic strength. Why gets basic strength. Oh ho ho. Now see what is guanidine. C double bond NH, NH2, NH2. Now H plus will attack where? Now see, check it out. This lone pair is delocalized. This lone pair is also delocalized. But this lone pair is localized. Why it is being localized? This is having pi bond as well as lone pair. Whenever pi bond and lone pair is there, this will do resonance, right? Now after accepting proton, now see, once this base got converted into conjugate acid, now this conjugate acid will form 3 equivalent resonating structure. That means it is highly stable. And once conjugate acid is highly stable, definitely the respective base will also be highly basic. And this is known as strongest nitrogenous organic base. This is known as strongest. Guanidine is known as strongest nitrogenous organic base. And my dear friends, this is the part of your amino acid arginine. Why arginine is most basic? Because of this guanidine. You know that there are 20 to 22 amino acids and 3 are being basic. Arginine, lysine, histidine. Out of these 3 amino acids, arginine is most basic because of this guanidine, kids. Because of this guanidine, guanidine is responsible for making it most basic. Now, second is guanidine type. What is guanidine type, kids? C double bond NH, R, NH2. This is guanidine type. Now, kids. Now, God has given lovely life. What is the meaning of lovely life and what is the difference? L, L. See, try to understand. Try to understand from your side, then I will let you know. In both the two compounds, lone pair is localized. This is sp3, can't do resonance, so this is localized. Here this is double bonding resonance, this is also localized. Now where is the difference? Now see, its adjacent is sp3 hybridized and its adjacent is sp2 hybridized. Remember that. It is attached with more electronegative carbon atom and that is attached with less electronegative carbon atom. This is the difference. Nitrogen is attached with more electronegative carbons. So you got the difference. This is more basic and that is less basic. You got it. Now just 2-3 minutes more. What is the meaning of God has given lovely life? Don't drink alcohol. DDA. Right? DDA. Only that is left. DDA. Just see. D D A. DDA. This is the basic strength of DDA. Now 1D stands for just try to understand the difference. This is aniline. This is pyrrole. And there it is amide. Now see the difference. Here this ring is already aromatic. The ring says, I don't need your pi electrons. Please don't come to the benzene ring. We are not IUPAC. I will teach. This is IUPAC is not the part of GOC. I will take it separately, okay? Isomerism, IUPAC, that I will take separately, okay? Hashim? Now, so this ring is already aromatic. Its ring is aromatic itself. Ring is aromatic without lone pair of nitrogen. This I have written for this ring. This I have written for this ring. This I have written for this ring, okay? This I have written for this ring. But here, this ring says, I can't live without you because I am aromatic with the help of your lone pair. So, this lone pair is slightly delocalized. Slightly delocalized. This lone pair is highly delocalized. And see there, this is delocalized, but these lone pairs are localized, but its electronegativity is 3.5, so can't attack. Proton can't easily attack. Very least basic. So this is highly delocalized. So where attack is easy, slightly delocalized. Here The attack is super awesome, super easy, so it can easily attack. I told you each and everything, kids. Completed the whole GOC. I've gone through, kids. I told you each and everything about GOC. How was the lecture? Once the class is over, oh, Sandhya Urmila is asking for when you will teach inorganic. Kids, I really thank you from the internal core of my heart. You people are giving me that much of respect. Thank you, kids. Really, thanks. Really, lot of thanks. And I would like to pray to Almighty God that these kids are so awesome. These kids are giving answers so nicely that Almighty God, please take care of these students. Kids, there was a lag, but right now I think it's okay. So bye to all of you kids. The end. Notes I will give you, I will share. I will share the PDF. Don't worry, kids. Notes will be shared as soon as possible. Bye to all of you. Bye bye, kids. See, the notes are getting copied. Okay. Bye bye, kids. Once you wake up in the morning, whenever you are going to wake up, do let me know once this video is over that how was it, how was the questions we have done today, number of questions, what you liked most, did you understand each and everything, have you got it, have you got each and everything, you were able to understand each and everything. Do let me know in the chats, not right now, once in the form of comments once this video is over, kids, right? Bye bye. Bye bye. What to say, good night or good morning? What should I say, good night or good morning? I don't know, kids, what to say. It's good night or good morning. Whenever you get time, do proper revision. That is the key to success, kids, right? Proper revision is the most important thing, kids. 11, yes, I too remember, how I can forget you. I can't. Okay. Bye bye, kids. Okay. Chalo. Let's go for sleep. Okay. Bye, kids. Hema. Okay. You are Hema Hames. Bye bye. Bye bye, kids.